most of the dissolved O2 in the solution, and after 4 hours, nearly none, and then no oxygen near the root tip. But the case of rice, oxygen concentration also declines. However, it becomes stable around 60 micromolar. So consumption and release balanced in the case of rice single crops, and mixture is in between rice single and palmier. In the case of rice, again same water culture experiment. However, physiological activities of upland crops mixed with rice under O2 deficient condition. For example, photosynthetic rate, micromolar CO2 fixation per square meter leaf per second. For palmier plant, 3 different conditions: aerated single plant, hypoxia mixture with rice, and hypoxia single palmier plant. Aerated single palmier plant, photosynthetic rate is quite high because this is aerated condition. However, the case of hypoxia condition without no oxygen bubbling, then photosynthetic rate declines after say around after a few hours after. Then even 20 hours later, photosynthetic rate is nearly 1/3, less than 1/3 of the aerated condition. However, the case of mixture with rice, photosynthetic rate is just in between medium rate. And the case of sorghum plant, mixture is nearly aerated single. Photosynthetic rate is nearly 1/3, less than 1/3. We try to estimate O2 transfer between the 2 species. For this purpose, we have constructed the root chamber to precisely control over the environment and measure the oxygen release to the water culture. We need to control the temperature, water temperature and room temperature, and we need to repeat. In fact, we have repeated more than 20 times, and then we got the data, how much O2 transferred between the 2 species. So the distribution of O2 released from rice, also from shoot, will move to the root tip. But during the movement of oxygen to the root tip, some oxygen will leak from the root to the water culture. We call this apparent O2 release. And some will be reabsorbed by rice root itself, but some will transfer from rice to palmillet. This slide shows changes in O2 concentration of the water culture. The value, minus value, means O2 is absorbed by plant. So we call phase 1, this one is apparent O2 absorption. This is with shoot system. The oxygen moves both shoot system and also root system. And phase 2, this is net O2 absorption. The shoot system was removed and sealed, only by the root system O2 changes in O2 concentration. And phase 1 minus 2 equal net O2 release. This is already established method by some scientists to measure how much oxygen is released from root. Permeate also release oxygen to water. So single total, this is rice plus permeate minus just mixed plant mixture equal oxygen transfer. We have estimated that 4.4 micromolar O2 per root chamber per hour was transferred between the two plant species, not only from rice to permeate, also permeate to rice oxygen transfer. We cannot separate both two components. Now, I'd like to explain the background of cross-mix planting. Why we have developed such a bit strange cropping system. This picture was taken from the airplane, year 2002. First time I have visited Namibia. Namibia is a northwest African country known as desert country, which has Namib Desert, very old desert in the world, and also Kalahari Desert. However, in north central Namibia, the population is quite high because of this water. This is a seasonal wetland formed in semi-arid region. The annual rainfall is only around 300 to 500 millimeter per year. However, this flooding occurs every rainy season. People call flooded savanna. And the agriculture in this region is just permeate main staple food production. And this water was not utilized fully for agriculture. But as you can see, this water is a potential rice field. Rice can be easily introduced to this region. That is why we have initiated the rice introduction project, started from 2004. The start line was very small research funding from Japan, Japan Society of Promotion Science, until 2013, with the University of Namibia scientist and also myself. These pictures are the seasonal floodplain, seasonal river inside the University of Namibia North Central campus. And all the pictures were taken from the same place. Year 2006, just after the initiation of rice introduction project, the water level is quite fine. These are grasses. However, rice can be introduced in such a water level condition. So we have started to grow rice in this place year 2009. However, water level goes up gradually and finally it reached nearly 1 meter and all rice disappeared because we were not growing deep water rice at this time. Year 2010, rice is growing. The potential yield is without no fertilizer, nothing, and around 2 tons per hectare. Because in Africa, rice average yield was around 2 tons, so this is just fine without no fertilizer. However, year 2013, all disappeared again because of very severe drought. This is the reason why rice were not grown there. People could not introduce rice in this place. Sometimes flood, sometimes drought, and nowadays these are very quite common in this region. Fluctuation flood water in a seasonal river, we have to overcome this phenomenon. This picture is taken also from the airplane year around 2004-5, something like that. Well, once again, parmet is grown in the field. These are the house quarters, and near the house quarters, parmet is grown. And our target was rice introduction to the seasonal floodplain. However, during the flood year, water goes up to the near the household, and then parmet all disappear because they are quite strong to the dry condition, but very weak to the water stagnant condition, wetland condition. And rice grow very well once we introduce deep water rice. However, during the drought year, all disappear except rice in the deepest place in the floodplain. So we have initiated the rice parmet satellites project starting from year 2012 until 2017, and I'm the team leader of the project, quite big project. We thought either rice or parmet survive, that is fine to overcome this water fluctuation. So just mixed cropping is the target of the project. Well, this is one of our demonstration farm and taken 20 January 2014. Rice was grown in water and parmet in upland. However, farmers need the survival of both crops. Therefore, we have introduced a cross mix planting. This is also open access figure. During the normal year, the water level is a red mark. Rice in water and parmet in upland. And water fluctuation zone mixed seedlings. All rice parmet can be grown. And during the flood year, flooding, water level goes up. However, because of cross mix planting, parmet can survive in water. And during the drought year, water levels goes down, and rice also can survive. I'll explain this later by the hydraulic phenomenon, water supply from parmet to rice roots. So this system can be introduced water fluctuation zone, and this system can be applied to the similar environment in the world. This is our main topic of our research work. The picture was taken in our demonstration farm 2 March 2014. Rice flowers and parmet also matures. Both crops flowers in water and survive. We did a number of experiments in northern Namibia. This is one of our experimental paddy field. Mixed seedling survival was tested in this place, and also the yield analysis was done in the experimental farm. This picture shows the survival rate of mixed cropping. Red mark is mixture, cross-mix planting with rice, palmette, or rice sorghum. The survival rate of single, as compared to survival rate of single, survival rate all goes up, especially in the case of sorghum. It significantly goes up. And the grain yield of palmette and sorghum and mixed cropping. The red circle indicate flooding condition. Palmette yield. Single plant is 100 gram per square meter. However, mixed cropping is 190 gram per square meter. So this short-term flooding condition, this is flash flood stress. The yield goes up nearly double. This is our experimental result in the case of palmette and rice system. The detail, if you are interested in, you can see the open access journal, European Journal of Agronomy, Awara et al. Awara is my student, and he's now the department head of this Ogongo campus. In the case of mixed cropping, total yield is quite important. So we have the two concepts. One is land equivalent ratio. This will be can be applied in the case of field experiment. You can see the blue colors calculations. The ratio of mixed and single and total. Please look at just the red numbers and the flooding palmette. Partial ratio is already 1.86. More than 1 is successful in the case of total LER. So total LER under game ratio 2.55 is quite high. A complementary effect is very high in the case of short-term flooding and sorghum as well. In case of drought environment, cross-mix planting rice and palmette, rice can mature in a dry condition. Palmette can help rice under drought condition by hydraulic lift phenomenon. During night time, water absorbed by palmette will be leaked to the surface soil, and then during daytime, rice can get this water. We have proved water supply from palmette to rice by hydraulic lift phenomenon. In a vinyl shed sloped experimental field constructed in Japan by using deuterated water. This is stable isotope, so quite safe to be used in the field. When the deuterated water is supplied only to the palmette root by a model system, palmette root will take up this deuterated water, and then it goes up to the palmette. And when we measure deuterium water concentration at 2% excess in the rice plant, this graphic shows the rice plant deuterated water concentration. Under drought condition, the concentration was significantly higher as compared to the non-hydraulic lift or control condition, and we can prove water supply. Rice palmate cross-mix planting is fine as a basic research work. However, in the reality, in the field, palmate rice system cannot work, especially during severe drought year without water. This picture is also open access figure. A is palmate, B is sorghum plant. This picture was taken in a farmer's field. We did the number of field days for local farmers, and we have demonstrated cross-mix planting rice and palmate year 2013 and 2015-16 years. 3 years later, we found this one in a volunteer farm. This one farmer did by themselves. The farmer said, palmate helps sorghum in a dry year. So A, palmate will supply B, sorghum, water during the dry year. Because sorghum is weaker than palmate, so the farmer said, now we can grow sorghum in a drier region. Before this place, sorghum did not grow, but during dry year, we can also enjoy the sorghum harvesting. We have asked why you did this, and farmer said, because you said during field day. We really surprised by looking at this picture, this phenomenon. And now, Namibian lecturers, Simon Wara, right, and left is Pawena Hapo. Both of them got PhD in Kinda University. They are the colleagues of Sudarshan in the Nagoya University and also Kinda University. And now we have initiated new project, JSP, a small project, and the target is this system, palmate and sorghum. And this one because local farmers did by themselves and quickly expand in some villages. And this picture was taken just before the lockdown, February 2020. After this, we are communicating only through Zoom. And farmers' practice is now expanding very slowly, but I think this palmate sorghum system can work very well in a semi-arid region. At the moment, the growing soybean with rice in paddy field is still on the way of basic research work. But I believe someday we can see this in some place in the world. I hope. And we are doing a number of basic research works, and we would like to submit soon the result of soybean growing under the flash flood stress. Climate change causes unpredictable flooding and drought in many regions of the world. So I hope the combination of any crops with rice, soybean or rice, some other upland crops, or some other candidate of except rice offer oxygen.
Thank you very much, sir, for joining with us today.
I think thank you very much. That's all my presentation.
Okay, thank you very much. This is the end of my talk. Thank you for listening. Mr. Chairman?
Can Thank you very much, sir, for joining with us today. I think it was a knowledge-filled keynote speech. Your knowledge and your experience shared through this online platform would be help to us to enhance our knowledge. Thank you again, sir.
Thank you.
Okay, ladies and gentlemen, now time is to move last item of the program agenda of our inauguration. To mark end of the inauguration session of this national symposium, I would like to invite Mr. B.P. Sirvardhana for vote of thanks. He is the secretary for first National Symposium 2020.
Honorable Madam Vice Chancellor, University of Colombo, respected District Secretariat in Hambantota, our most valued invited guests and keynote speakers, dear scholars, ladies and gentlemen, it is my privilege to purpose a vote of thanks at the end of this occasion. On behalf of the first National Symposium on Agrotechnology and Rural Sciences 2020, and the entire fraternity of agrotechnology here together, and on my own behalf, extended a very hearty vote of thanks to all speakers and paper presenters for gracing our symposium, sharing with us your findings and opinions today. I have no words stronger enough to express my gratitude to Professor Morio Eljuma, a professor in Kinda University, Japan, and Dr. M.W.M. Veerakon, Director General of Agriculture, Department of Agriculture, for accepting our invitation for delivering very informative keynote speeches. Our sincere thanks to all members of the reviewing panel who were supporting us to review abstract to maintain the quality of the papers ready to be presented at our symposium. I also take this opportunity to express my thanks to our loving scholars for sharing their knowledge and experiences with us. All this would be a difficult task without the financial support of our sponsors, and we recognize them with gratitude for their lavish and significant contribution. I realize that I might miss a few individuals who have been supporting us, and I wish to be recognized them with a gratitude for their gratitude and the contribution. And finally, I must proudly remind Professor S. Sutarshan, our director, the strong pillar standing behind us, pushing us forward with regular inspections of our performances to gain marvelous experiences in organizing of this successful academic event. And we all members at this institute are very much thankful to you, dear sir. Thank you very much again for all of you.
Thank you very much, sir. He is the secretary for this National Symposium 2020. Okay, ladies and gentlemen, now we have come end of our inauguration. So this is the time to play national anthem. Thank you, everyone. Ladies and gentlemen, now we are going to start our technical sessions. In our this first national symposium, we have scheduled for technical session. So first, we would start technical session 1. So I would like to invite Miss SAP Nelka to conduct her technical session, and she is the session coordinator for technical session 1. I invite all the participants to join with us with Zoom link that we have sent. Okay, ladies and gentlemen, already we have completed our inauguration session and now we are going to start our technical sessions. First, you all are warmly welcome for our technical session, and first we would like to start technical session 1. So I would like to invite Ms. SAP Nelka to conduct her technical session. She is the session coordinator for technical session 1.
Thank you, Mr. Rasika. Welcome all for the technical session 1 in the first National Symposium on Agrotech. Rural Sciences 2020, Session Director, University of Colombo, Institute for Agrotechnology and Rural Sciences, and former Dean, Faculty of Agriculture, Eastern University of Sri Lanka, and he is a professor in crop science at Eastern University of Sri Lanka with significant administrative experiences as Director, Staff Development Center. Sir, I cordially invite you to conduct this session. Thank you.
Thank you, Ms. Nelka. I can all hear me?
Yeah.
Okay.
Yes, sir.
Okay. So let us start with the first presentation. That is the fatty acid contents of some popularized cultivars, that is the Orisa sativa of Sri Lanka. And I cordially invite Mr. MDW Samaranayake. Please.
I'm Madara Samaranayake, and title of my presentation is Fatty Acid Contents of Some Popularized Varieties of Sri Lanka. This is the content of my presentation. And let's move on to the introduction. Rice is a popular cereal crop growing across the world, and it is the dietary staple for nearly half of the world population, including Sri Lanka. Rice reported to provide significant quantities of nutrients, including fat, and rice fat reported to have high quantities of monounsaturated and polyunsaturated fatty acids compared to saturated fatty acids. In Sri Lanka, there are thousands of traditional and more than 60 new improved rice varieties, and most popular and widely consuming varieties are the new improved rice varieties. In addition to that, some traditional rice varieties of Sri Lanka have also gained consumer preference due to health properties. Up to date, there is extremely limited studies on fatty acid contents of Sri Lankan rice varieties. Therefore, the objective of the present study was to evaluate fatty acid contents of some popular rice varieties of Sri Lanka. Let's move on to the methodology. As for the materials, locally grown, 5 new improved and 3 traditional rice. Before analysis, factorize samples held and ground to obtain rice. Rice varieties determined by visual observation. Before analysis of fatty acid compositions, fat was extracted from rice flour and derivatized to fatty acid methyl esters using methanolic KOH and analyzed by GCFID method.
Automatical method.
Let's move on to the results and discussion. These are the monounsaturated fatty acid contents of studied rice varieties. There were 3 monounsaturated fatty acids. And major monounsaturated fatty acid was oleic acid, and content range from 9.15 to 11.69 milligram per gram of rice, and total monounsaturated fatty acid content range from 9.44 to 12.12 milligram per gram. There was no significant differences in total monounsaturated fatty acid between studied traditional and new improved rice varieties. The total monounsaturated fatty acid contents were significantly higher in non-pigmented or white rice varieties compared to pigmented rice varieties. These are the polyunsaturated fatty acid contents of studied rice varieties. There were 4 polyunsaturated fatty acids. Most abundant was linoleic acid, and content ranged from 6.97 to 9.11 milligram per gram of rice, and total polyunsaturated fatty acid ranged from 7.23 to 9.40 milligram per gram. There was no significant difference in total polyunsaturated fatty acid and linoleic acid contents between traditional and new improved rice varieties, but the total polyunsaturated fatty acid and linoleic acid contents were significantly higher in studied non-pigmented or white rice varieties compared to pigmented rice varieties. These are the saturated fatty acid contents of studied rice varieties. There were 4 saturated fatty acids, and major saturated fatty acid was palmitic acid and ranged from 4.35 to 5.62 milligram per gram, and total saturated fatty acid content ranged from 4.85 to 6.33 milligram per gram. There were no significant difference in total saturated fatty acid content between traditional and new improved rice varieties, but the saturated fatty acid contents were significantly higher in studied non-pigmented or white rice varieties compared to pigmented or red rice varieties. These are the total fatty acid content, total unsaturated fatty acid contents, and polyunsaturated to saturated fatty acid ratios of studied rice varieties. According to results, the total fatty acid content ranged from 22.00 to 27.70 milligram per gram, and total unsaturated fatty acid content ranged from 16.97 to 21.52 milligram per gram. The polyunsaturated fatty acid to saturated fatty acid ratio ranged from 1.25 to 1.60. The total unsaturated fatty acid content and polyunsaturated fatty acid to saturated fatty acid ratio between the tested traditional and new improved rice varieties were statistically insignificant. The total unsaturated fatty acid was significantly higher in non-pigmented or white rice varieties compared to pigmented rice varieties, but there were no significant difference in polyunsaturated to saturated fatty acid ratio between non-pigmented or white rice varieties and pigmented or red rice varieties. These are the conclusions and recommendations obtained from the findings of present study. The fatty acid contents varied significantly among the tested rice varieties. There were no significant differences in total monounsaturated, polyunsaturated and saturated fatty acid contents and polyunsaturated to saturated fatty acid ratios between the studied traditional and new improved rice varieties. The tested rice varieties had significant quantities of essential fatty acid linoleic, and the polyunsaturated to saturated fatty acid ratios were above 0.4, the minimum value recommended for a healthy diet. Therefore, generally tested traditional and new improved rice varieties may consider as healthy and have the potential to develop functional food products. And among the tested rice varieties, with respect to the polyunsaturated fatty acid to saturated fatty acid ratio, the traditional rice variety could have been the superior. Finally, I would like to thank the Industrial Technology Institute Treasury for funding this research study, and Dr. Senanayaka, the Director of Rice Research and Development Institute, Bapalagoda, for providing rice samples for the study. Thank you.
Thank you very much, Senanayaka, for a nice presentation. Now, today is in the keynote address that our Dr. Peter Pon clearly stated that we are the rice eaters and we are consuming more rice. And your study is about the saturated and the unsaturated fatty acids towards the traditional and the newly improved varieties of the rice. Can you just give an idea how the saturated and unsaturated fatty acid content of the rice varieties might have an influence on the health concerns of the people of Sri Lanka?
Yeah, in Sri Lanka, the dietary staple is rice. Therefore, the fat content is low, but the brand, if you take the brand, the fat content is 19 to 25%. If you use that brand for functional food products, you can get the health benefits from rice. Because the monounsaturated and polyunsaturated fatty acids, they help for they have a lot of health benefits. They can reduce the cholesterol level and mainly affect for heart diseases. Therefore, we can use this oil from rice to get a lot of benefits from the rice oil. In Sri Lanka, we are not using the rice oil much, but we can use that because in other countries, in other international countries, already they are using rice bran oil and bran incorporated functional foods. I mean, we can also go for that.
Okay, thank you very much, Ms. Amanaka. So I think we can move to the next presenter. The next presentation is going to be on the efficacy of seaweed extract on chili leaf curl virus, which will be by Dr. Vairadan. I warmly welcome Dr. Vairadan to deliver his presentation. So over to you.
Good morning, ladies and gentlemen. I am Dr. K. Bhagirathan. I would like to present at the National Virtual Symposium organized by the Institute for Agro-Technology and Rural Science of the Colombo University of Sri Lanka on the title of Efficacy of Seaweed Extract on Chili Leaf Curl Virus. You all know it's one of the important cash crop grown in Sri Lanka. It is native to South America. The chili is mainly cultivated in Sri Lanka in the dry zones of Sri Lanka, mainly Central Province and Intermediate Zone. So as per the Department of Agriculture, the chili per capita consumption is nearly about 2.84 kilogram per year. Therefore, we have to import nearly 52,849 tons of the per year to satisfy the consumer demand. So chili cultivation is facing the problem due to the biotic and abiotic stresses. The abiotic stresses, chili leaf curl virus is showing the 100% even yield losses under improper management and improper monitoring conditions. This chili leaf curl virus disease is caused by the virus belongs to Benomyvirus family of the Gemini viridae has become highly important in recent years in Sri Lanka. This is transmitted through the whitefly and an insect, vector. The symptoms of the chili leaf curl viruses are the several leaf curl with a cup-shaped and upward curling leaves and yellowing and stunted plant. Leaf curl virus transmitted by the vector whiteflies, and this is the leaf curl and leaf puckering. So this chili leaf curl viruses can be managed through the cultural, physical and mechanical, biological and chemical method. Even though due to this chemical health hazards nature due to the chemicals, the scientists are recommending to use the natural extracts to manage these diseases. So one of the natural extracts is the seaweed extract. The seaweed extract is highly recommended to increase the plant immune and the growth and yield of these plants. Therefore, our objective is to evaluate the efficacy of seaweed extract on chili leaf curl virus management. So for these experiments were followed. So the material for as a text cultivar. This experiment was conducted on the Field Crop Research and Development Institute, Mahalapalam. This is the experimental design. So two-factor factorial experiment conducted with the 6 treatment and with the 3 replicate. Nursery management and the field management and the agronomy practices according to the Department of Agriculture recommendations. For our experiment, there are 6 treatments including the control. This you want to take for the varies with number of times the seaweed extract applied in the frequently 2 to 3 times, and treatment 4 and indicates that seaweed application T3 and T4 is a C4 is seaweed extract application intermittent with the insecticide application. T5 is the purely an insecticide applications. From this experiment, the number of days for 50% of flowering, the plant height, yield per hectare, severity of the chili leaf curl viruses were measured through the scale mentioned into 0 to 4 and to 100% disease severity insect based on the formula mentioned in this slide. So this measured data was analyzed, subjected to the analysis of variance through the SAS 9-point versions of given to the students through the university package, and the Duncan multiple range test was chosen to identify the best treatment combinations showing the highly significant from the experiment. So these are the results received from these out of 6 treatments, including the control. So the chili leaf curl virus disease severity varies with number of days among the plants. So T3 and the T4 shown the less disease severity index of 43 and the 14. This is because of the first application of the CBD extract on 10-15 days interval, and the 10 to 15 days interval with an insecticide. So this is the number of days for 50% of flowering. The plant height was not significant among the treatments, but the yield was significant in T3 and T4. From this experiment, so this we can support that application of the CBD extract not only induce the immune of the plant but also increase the yield through the giving some of the plant physiological changes, including inhibiting binding of the internalization of the virus host cells. From this experiment, we can conclude that the first application of the CBD extract, the 15 days with the planting, and then thereafter continuous application of the CBD extract with an insecticide increase the plant yield as well as reduce the chili leaf curl virus incidence. So thank you very much for also. I would like to acknowledge that the Institute of Ecotechnology and Rural Sciences for giving me opportunity to present, the University of Jaffna for to conduct the experiment and the presentation and conducting the research. Thank you very much for your kind patience.
Thank you, Dr. Bhairavan. It was a nice information to gather how the CV have an impact on controlling the chili virus. So now CV, this is one of the important area that we also need to consider. But when we are going to have you ever considered about the sustainability of the CV when we wanted to recommend control measures using this one?
Sorry, sir.
Okay. Have you ever considered? Can you hear me?
Yeah.
Okay. If we are going to consider the seaweed for controlling, maybe now it's not a problem, but for the future, whether there's a possibility for the mass production of the seaweed in an artificial way for sustainability of the continuation of this type of methodology.
Yeah, in northern Sri Lanka, the NACTA has identified the areas to cultivate these seaweed extracts. So they are cultivating nearly the Punagiri area and Mandativu area and the mass production of the seaweed extract. I hope that it will not be a shortage in future for the extraction of the seaweed extracts to test on these different experiments related to the plant physiology and plant pathology, or the fertilizer, check as fertilizer for plants.
Okay. Thank you very much, Dr. Bhairavan. I think we can go to the next presenter. So next presentation is going to be on the comparison of the growth rate of Central Asiatica under chemical and organic management. So I kindly invite Ms. Govina to present the findings, please.
Hello, have a nice day. I'm Sakuntala Govinda. Comparison of the growth rate of Central Asiatica under chemical and organic management is my research. These are our research team. Sakuntala Govinda, Professor Priya Yapa, Mrs. Sudhinaratna. Then we'll see the introduction. Central Asiatica is an important herbal plant. Here is the classification of Centella Asiatica. Centella Asiatica is a perennial creeping plant. It can cultivate in every agroecological regions in Sri Lanka. Centella Asiatica can grow under full sunlight and partial shade areas. Centella Asiatica used as human food and as medicine. There are fertilizer fertilizers which are used in my research. I used supercompost as organic fertilizer. Supercompost is special type of organic fertilizer. I used inorganic fertilizer, government recommended conventional fertilizer mixture. Here are the research problems which are identified. In present, we can find so many health problems around our foods. Organic food is healthier, safer, and as a result, the demand of organic food is ever growing. The other thing is government spend huge amount on subsidy of chemical fertilizer from one side and bear huge cost on health care from other side. If we use organic foods, it will help to reduce both two subsidies. Promotion of organic leaf crops minimize the health problems and increase income. Main objective of this study is to study variation in growth of Centella asiatica under different fertilizer composition. Compare the yield organically grown and non-organically grown and identify suitable fertilizer type to obtain high yield are specific objectives. That are the methods and materials I used. I analyzed soil pH, soil EC and compost. Experimental design was complete randomized block design. There were 3 treatments, T1 with super compost, T2 with chemical fertilizer, T3 without fertilizer. 3 replicates and 3 blocks. Obtained growth and yield parameters. Number of leaves, stem length per plant, diameter of leaf per plant are growth parameters. Fresh and dry biomass without roots, yield parameters. Preparation of supercompost, ingredients and quantity. Stages of production supercompost. Preparation of rich microbial solution. Land preparation stage. The experiment was conducted at Faculty Farm, Faculty of Agricultural Science, Sabaragamuwa University, Sri Lanka. The soil of the experiment site was clay loam. The cuttings of plantlets were uniform size with 4 leaves in each. The plots were uniformly irrigated once in every 2 days. Altogether 324 plants, 36 plants for each treatment were planted. Department of Agriculture Sri Lanka recommended fertilizer mixture and compost mixtures were applied as follows. There was not any pest attack or disease observed. Harvesting. After 2 months, plants were harvested 2 cm above ground level. Data collecting. Plant stem length, number of leaf per plant and leaf diameter of a plant are the vegetative parameters. Those parameters were measured after 2 weeks of planting to end of the crop cycle in 7 days interval. Fresh weight of leaves and dry weight of leaves were measured as yield parameters. Data analysis. The significance of the difference between the mean of measured attributes among the fertilizer type was analyzed by one-way analysis of variance. Result and discussion. Plant stem length, number of leaves per plant and leaf diameter of plant are the vegetative parameters. Fresh weight of leaves and dry weight of leaves were measured as yield parameters. Electrical conductivity was measured by using caliper calibrated electricity conductivity meter. Soil electricity conductivity was 28.6. Soil pH was 6.75. Here is the compost analysis report. I obtained it from the Research Institute of Talakali, Sri Lanka. Composition of supercompost. Stem length per plant, number of leaves per plant and leaf diameter of a plant. That's our vegetative parameters. These parameters were measured after 2 weeks of planting to end of the crop cycle in 7 days interval. Fresh weight and dry weights biomass without roots. That's are the yield parameters. Fresh weight of leaves were measured after harvesting and it was measured by analytical balance. Dry weight were obtained after oven drying for 12 hours at 105 centigrade. Conclusion. There was no significant difference among the treatment on vegetative parameters such the plant stem length, diameter of a leaf per plant and number of leaves. At 4 weeks after planting and next, from 8 weeks after planting to the end of the crop cycle, was also observed the same result on vegetative parameters. There was no significant difference among the treatment on yield parameters, which are fresh and dry weight biomass without roots after 8 weeks of planting. To meet the nutrient requirements of short duration crops such as Centella asiatica, organic sources may be appropriate. Therefore, the present study was undertaken to evaluate the effect of organic amendments. Proper fertilizer management for medicinal plant species is important for increasing its yield and maintaining the quality of active principles. To increase the crop quality, especially of medicinal and aromatic plants, organic fertilization is more accessible than the chemical fertilizer. According to the study, it can be concluded that the supercompost can be used as a fertilizer for Centella asiatica than inorganic fertilizer for mass cultivation with less health risk. Recommendation: the repetition of this research should be done in 1 or more times in the same environmental and geographical conditions before the recommendation. References. Thank you.
Thank you very much, Ms. Govinda, for your nice presentation, and it is an informative for how the importance of Centella asiatica with different sort of fertilizers. Can you just explain us what is super compost and how it is different with normal compost?
Yes, it's somewhat different from the normal conventional we prepared compost, because normally we prepare the compost by using decaying materials, cow dung, and likewise thing with the decomposting process. In super compost, it's a little bit different because we add epaval rock phosphate, ERP, and feldspar, and also biochar, Jivamurtam, likewise thing. So then it nutrition value was little bit increase than the super normal compost. That is the difference between compost and super compost. Nutrition's value, we analyze those things, compost and super compost, then we can identify the difference of both.
Okay, thank you very much. So it is a value-added compost, I would say.
Yes, of course, sir.
Right. So then it is a good information for the members in the country to have a better value-added compost for the better growth of even Central Asiatica. It is a leafy vegetable that we are looking for. Okay,
Yes.
thank you very much. I think we can move on to the next presenter.
Thank you very much, sir.
So the next presentation is going to be on the screening of the most appropriate cladding material for parachute nursery of rice in the dry zone of Sri Lanka. So I cordially invite Mr. Kumar to deliver the presentation, please.
Good morning, yes, madam. Yes, sir, madam. My topic is screening of the most appropriate cladding material for parachute nursery in rice. In parachute nursery technique in rice cultivation, it increased the paddy yield because it increased the curing ability of the plants, and it suppressed the weed growth because as the crop establishment method, we use seedling broadcasting as the crop establishment method. So the rice plants can compete with the weeds easily. By this, it increased the paddy yield in the parachute cultivation, in parachute nursery technique, use paddy fields. But this parachute nursery technique is mainly practiced in young season, because in the last season the seedlings are damaged by the heavy rainfall. Therefore, a measure to protect the seedlings in last season is important. So, our objective was to protect the seedlings from rain by applying cladding material and to select freely available, low-cost, appropriate cladding material and to identify the effect of cladding material on growth and development of rice seedlings. For this experiment, we have 5 treatments. The T1 means control, use no mulch and polythene mulch, straw mulch, coconut kerjan mulch, newspaper mulch, and the experimental design was RCBD with 3 replicates. The procedure was place the parachute trays in paddy field and fill the parachute trays with mud in the paddy field and place pre-germinated seeds in trays and covered with the different cladding materials, and observations were made. When we consider the performance of seedlings under different cladding material, when we consider the number of seedlings imaged, the highest number of seedlings imaged was recorded in newspaper treatment, while the lowest number of seedlings imaged was recorded in mulch treatment and straw mulch treatment. When we consider the plant height at seedling broadcasting, the highest plant height at seedling broadcasting was recorded in newspaper treatment, while the lowest plant height at seedling broadcasting was recorded in polythene mulch treatment. When we consider the fresh weight, the highest fresh weight was shown by newspaper and coconut kerjan mulch treatment, while the lowest fresh weight was shown by polythene mulch treatment. When we consider the dry weight, the highest dry weight was shown by newspaper mulch treatment and straw mulch treatment, while the lowest dry weight was shown by polythene mulch treatment. When we consider the root length, the highest root length was shown by coconut kerjan treatment followed by newspaper treatment, while the lowest root length was shown by straw mulch treatment. And when we consider plant height at 30 days after seedling broadcasting, the highest plant height at 30 days after seedling broadcasting was shown by newspaper treatment and coconut kerjan mulch treatment, while the lowest was shown by polythene mulch treatment. It indicates when we consider the cost involvement for establishment of a nursery, which required for 1 hectare of paddy field. The highest cost involvement was recorded in coconut Khajan, and the lowest cost was recorded in a normal treatment because it is normal. And with these results, we can summarize that there was no significant difference among the treatments, but visually the plants look better with newspaper mulch, and the cost involvement is less in straw, but seedlings are damaged at the straw removal stage, and it contaminated with weed seeds and straw particles. So, with these results, we can conclude that application of any kind of trading material is beneficial for parachute nursery, and the polychain would be a better option for rainy season, but not biodegradable. So it is better to come up with parachute nursery with any easily available low-cost material to protect the seedlings. Thank you.
Thank you, Mr. Kumar. So your finding is there is no significant difference among the different trading materials. So that you wanted to say any locally available low-cost material can also be used as a trading material for the parachute nursery. So is there any other thing that you wanted to convey to the farmers when you consider the farmers' perspective, how they can utilize this information in their real field?
Sir, mainly in yellow season, the practice, as I told earlier, but in March season, we have a big issue in finding so-called Kajans because they are not freely available, and we have to expend more cost on coconut Kajan. So now the farmers are getting informed that the newspaper are better.
Okay, thank you very much. So let us move to the next presenter. And it is going to be on the oyster mushroom production using agro-based industries byproducts. So once again, I am happy to invite Dr. Bhairavan.
Very good morning, ladies and gentlemen. I am Dr. K. Pakiradan. This is a great opportunity to me to present the first national virtual symposium organized by the Institute for Agro-Technology and the Rural Sciences of Colombo University of Sri Lanka under the title of Oyster Mushroom Production Using Agro-Based Industries Byproduct. So these are my content of the presentation. So this the content of my presentation, starting with the introduction and ending with. So I would like to go through my presentation through an introduction. So you all know the mushroom is the source of protein, and oyster mushroom is also known as the poor man protein. So this consisting a rich source of nutrition. Therefore, this is famous among the farmers and the consumers. But the farmers prefer more to cultivate this oyster mushroom because of it needs low investment and it is giving higher revenue from these productions. But the major hurdles of these oyster mushroom productions are the mycopathogenic contaminations. Therefore, was to determine the growth and yield performance of the Pleurotus ostriatus using agro-based industries byproduct. So I would like to go through my presentation, the materials and the methodology. So for this experiments, there are 4 commonly available substrates were used: paddy straw, paddy husk, wood sawdust, and the banana leaves. These available substrates were treated with the 2% coffee ground and the tea grounds and mahua oil cakes from these agro-based industries along with this experiment. Each substrates were treated with a selected dry powder of 2% root extracts in 2% rate, and sterilization of these prepared substrate bags and inoculated with the 14 days old mushroom spawn and incubated for the growth and reproduction. So after the growth and from these 7 days from the incubation, the recording the parameters were recorded. So parameters are the spawn run days and pinhead formation days and the yield of this oyster mushroom in different sub. So these experiments were conducted under the complete randomized design. This is the our experimental plan. So these are the treatment and these are the substrates. So this after after the collection of the complete data sets, these data sets were statistically analyzed by using the UCIARS. Thereafter, the mean separation and analysis of variance performed by using the Duncan multiple range test to show the best combination of these treatment and the material for the production of these oyster mushroom and prevent the contamination of this oyster mushroom. So these are the results and discussion. If you are taking the first average spawn run days, so if you are taking this paddy straw, the paddy straw with the tree and the paddy straw with the coffee, it showed this average spawn run days of 20 days, which is the minimal in compared to the other treatments. So if you are taking the mehua, it always showed the higher run, it took higher run days for the spawn runs, but it indicates that this mehua have some antifungal effect. If you are taking the pinhead formation, the lowest pinhead formation was observed in the paddy straw, thereafter paddy straw and the coffee and the paddy straw with the tea. So this is these are not significant among the treatment. If you are comparing with the paddy husk mehua and the mehua treated all the substrate, showing it took long days and it is significantly different in comparison with the tea and coffee added paddy straw substrate. So this is indicating that we cannot use for the mehua as a substitute for any mushroom industries. So if you're taking an average yield of these mushrooms, for example, paddy straw and coffee treated gave an highest yield of 200.67 grams. This is 14% higher than the paddy straw alone. That indicates that so we can use this coffee as a substitute or the fraction substitute for the raw material paddy straw. So the paddy straw thereafter the tea was showing the second highest yield in the wood dust and tea combination. So this was nearly 185 grams, and thereafter wood dust and coffee also showing the higher yield of 125 grams. So this indicates that if you are adding the coffee and tea to the materials, so this is increase the yield, therefore the highest profit from this induction. So this is my presentation. Plant extract did not arrest oyster mushroom growth and reproductive parameters. Paddy straw mixed with the coffee and tea, the best substrate for oyster mushroom cultivation. Mehua treatment shown some anti. These are my presentation. This is an acknowledgement. I would like to acknowledge Institute for Agrotechnology and Rural Sciences for giving me an opportunity to present in this symposium, and University of Jaffna to conduct my experiment. Thank you very much for the audience and the participant and the scientists. Thank you very much for if you have any questions.
Thank you, Dr. Bairdad. So, in your experiment that you have used a factorial experiment, have you analyzed the interaction effect of these two?
So, the interaction effect we were used to analyze, but the interaction of these paddy straw with the other coffee and tea gave the significant, but in the substrate interaction for the paddy straw and the wood and the banana leaves did not show any interaction effect. So that's what we haven't concluded. We are doing again to find out what's happening with the.
Okay.
Thank you. It is also to see that interaction because that also have some indication where and how we can lead the experiment.
Yes.
Okay. Thank you very much.
Thank you.
So let us move to the next presentation. Yeah, it's again Dr. Bhairavan. It's about the identification of the causal organism of wilt disease in black pepper in nursery stage and its management. Over to you, please.
Very good morning, ladies and gentlemen. I am Dr. K. Pakiradan. I would like to present in the first National Virtual Symposium organized by the Institute for Agrotechnology and the Rural Sciences of Colombo University of Sri Lanka under the title of Introduction of Causal Organism of Wilt Disease in Black Pepper in Nursery Stage and its Management. So my presentation contents are the introduction, objectives, materials and methodology, results and discussion, conclusion and I would like to go through my presentation through an introduction. You all know the black pepper is called as a Piper nigrum, belongs to family Piperaceae. It's a king of spices. It is a very economically important minor export crops in Sri Lanka. It is producing so much of foreign income to this Sri Lanka. This pepper production is facing major problems related to that. So an average of 20 to 30% of the planting materials of the pepper is getting lost due to these diseases at nursery stages. Among the diseases, pepper wilting disease are severe in intermediate agroecological zones of Sri Lanka. So these disease outbreaks, we call it as an wilt, is caused by the Pythium, Phytophthora and Fusarium. So therefore the pathogenetic test decides which fungus is responsible for this pepper wilting disease in Sri Lanka. The farmers, without identification of these diseases, they are applying the fungicides and they are doing the soil solarization to manage these diseases. Therefore the objective was to identify the exact causes for the outbreak of pepper wilting and to propose a suitable fungicides for effective control of the disease at nursery level. To achieve this objective, the following materials and methods were followed. So the disease samples were collected from the nurseries located in Matala, Kandy and Moragala districts of Sri Lanka. So thereafter these samples were brought into the laboratory for the identification and the testing of confirmation of these. So for the isolation of this Phytophthora capsicum, soil baiting techniques were used. So for this experiment, 200 grams of infected soils were brought into the laboratory and it is mixed and with an excess amount of sterilized distilled water. Thereafter these tender healthy black pepper leaves were immersed. Thereafter this top of this beaker were covered with the transparent polythene and kept it for 2 days. So thereafter the symptoms were developed from that one, so were trapped. For isolation of the Phytophthora capsicum from the leaves, the serious light dilution plate techniques were followed to isolation of these Phytophthora capsicum. For the isolation of the Phytophthora. So this is the serial dilution method used to isolate the Pythium species from this infected seedlings. For the after the isolation of these pathogens, for the confirmation, so the experiment that in vitro experiments were conducted. For that, the 5 kilogram topsoils were collected and mixed with cattle manure, coir dust and sand in 1:1 ratio. These were sterilized, these potting mixture, so solarized for 21 days. So these following first set of experiment were designed to confirm the diseases, whether they are, which pathogens are causing these diseases of pepper wilt in China. So thereafter another in vitro experiment work planned. This is called fungicide assay. For that one, sensitivity of the causal agent of these three recommended fungicides was selected: topsin, homine, redoxamil, and metalaxyl. At the Department of Agriculture recommended dosage of 6 gram, 10 gram, and 25 gram per liter. So that from that one, this is a concentration of these different fungicides. So, and here 3 different concentrations were selected from the each fungicides, and with the so these after the experiment, these data collected were analyzed. The variants were analyzed by using the SARS of 9.0%. For our research showed that these lesions confirm that these are caused by the and the pythium. So this is a re-isolation and confirmation of these from the morphometry characters of these the pear-shaped sporangia as well as non-septate are indication of these phytotoxicity and pythium. In the fungicides experiment, so it shows that the homine at the concentration of 960 is managing the both Phytophthora hepsisi and pythium. Redoxyl and metalaxyl at the 3 concentrations also, they are completely arresting the growth of these both pathogens. So from this experiment, it is concluding that Phytophthora hepsisi and the pythium are the responsible for causing the wilt, and at the homine at the 960 ppm, and at the redoxyl, metalaxyl and 1440 and 1880 and 2160 ppm can be used to manage these diseases successfully. So this is an references of my presentation. Thank you very much for all for the kind and patient for the presentation. Thank you very much for all. Thank you very much.
Thank you, Dr. Vairadan. It was a very informative and very nice presentation. Just one thing, just to clarify. Now this, now the homine and the other chemical is performing better in eradication of this problem for these king of pines, that is the pepper production in Sri Lanka. Now, how is the problem of the pesticidal residues in the case if we go and use these plants? If there is any bad effect or ill effect towards the production? Any suggestion from your side?
So actually, we selected this pesticides assay because we are not consuming the pepper in seedling stage. So we are going to harvest the fruits when it's reached full grown. For it's a perennial plant. So therefore, we haven't checked the residual analysis. But if it is an annual plant, so definitely we should not go for a recommendation of these pesticides, because we can go for other biological treatment. And another set of experiment is we are planning to compare with the trichoderma, because these are soil-borne pathogens. So we are doing that one to compare with the trichoderma and the pesticides. These identified these 2 fungicides. If it is trichoderma works well, then definitely we should not recommend these fungicides, and we are now mass producing of trichoderma and testing on other pathogen, and we can recommend the farmers and these pepper seedling producers to use this trichoderma mixed with the bedding material on the nursery. Then it can arrest that soil-borne pathogen, I hope.
Okay, thank you very much. Because the concern is when now we are mainly targeting this pepper is for the export market, getting a higher return. But when it is having a problem of this one at the end of the stage of harvesting and for the exporting, the similar problem but we face for the rice and the similar problem for the tea might come up again. So that will have a negative impact in the future. So that's what I.
The problem of this pathogen, sir, it is in the seedling stage. So we have to secure the healthy seedling. That's healthy what we use that. Healthy seedling.
That's correct. Okay, thank you very much. It was very interesting.
Thank you, sir. Thank you, sir.
Let us move to the next presenter. So the next presentation is on the impact of an improved organic soil additive, that is super compost, on growth and quality parameters of Gotukola, that is again Centella asiatica. So I invite Mr. Balasuriya to make your presentation, please.
Balasuriya, I'll be talking about the impact of organic soil management on vitamin C content of Centella. My teammates are Mrs. Supiti Navaratna, Professor P.I. Yapa, and
Production. Centella asiatica, also known as gotugola, is a perennial herbaceous creeper with kidney-shaped leaves which grow in shady, moist or marshy areas. Centella asiatica is used as a leafy green in Sri Lanka and has rich sources of many nutrients. Gotugola has a lot of medicinal properties too. Supercompost is a more potent version of compost and is used in combination with farming skills. Problem statement. The productivity of food was increased, however the nutritional quality of the food was decreased due to the usage of inorganic fertilizers. Significant amounts of magnesium, iron, vitamin C and phosphorus and lesser nitrates and lesser amounts of heavy metals are found in organic crops. Higher amounts of nitrates and heavy metals in conventionally grown foods using inorganic fertilizer. Consumers have recognized that organic vegetables have a nutritional and toxicological benefit more than conventional vegetables. Therefore, study focused at enhancing the nutritional quality of Centella asiatica using organic fertilizer. The main objective was to identify the impact of organic soil additive on growth parameters of Centella asiatica. The specific objective was to assess the effect of supercompost fertilizer on vitamin C content in the harvest of Centella asiatica as a quality parameter. This is the experiment site used. Complete randomized block designs, or known as RCBD, with 3 replicates was used. The following treatments were done to the Centella asiatica. The treatment 1 without fertilizer, treatment 2 with the application of supercompost, and treatment 3 with recommended inorganic fertilizer. This was the land preparation for the experiment. Before the experiment, the soil sampling and analysis showed the pH value of the soil as 6.67 and EC as 28.6. Following parameters were used for this collection of data. Growth parameters was the width of leaves, stalk length, leaves per plant, and roots per plant. Quality parameter was average vitamin C content per 100 grams. Analysis of the collected data was carried out as an ANOVA procedure, and comparison of mean was done by a DMRT procedure. After the lab results, these results are shown of the soil. These are the comparisons of the treatments. And after the treatments, this was the average vitamin C content per 100 grams in treatments without fertilizer, treatment with the application of supercompost, and the treatment with recommended inorganic fertilizer. Conclusion. Both recommended inorganic fertilizer and supercompost were significantly increased stalk length and width of leaves of Centella asiatica plants. With respect to the analyzed results of the study, the significantly highest vitamin C content of Centella asiatica plants was observed by supercompost applied treatment with compared to other 2 treatments. The amount of vitamin C in foods of plants origin depends on the soil conditions and the nutrient management. The results clearly indicate that supercompost alone can be used to produce food with high amount of vitamin C. Therefore, compost should be considered as an alternative to inorganic fertilizers while improving growth and nutrient quality of plants. Thank you.
Thank you, Mr. Balasurya, for the contents of Centella asiatica and main focus on the vitamin C. Now, I have 2 things to ask you. Now, what is the reason, or do you have any specific reasons for consideration on vitamin C content in Centella asiatica? I think you are muted. Please unmute. Okay, do you have any specific reason for, considering the vitamin C content in this Central Asiatica?
මම සිංහලෙන් කතා කරන්නේ අපේ ඕගනික් වල පැවුවාම නිව්ට්‍රිෂන් වල එක වැඩි කියලා කියනවා. ඒකෙන් මම ඒක ඔප්පු කරන්න අපි එකම දෙයක් තෝරගත්තා ඒසිට ලේසි විදියට විටමින් C විතරක් නැත්නම් ඔක්කොම ටික තෝරගත්තේ නැහැ මේ වෙලාවේ අපි.
Okay, thank you. So let us move to the next presentation. That is on the development of low-cost feed for tilapia fry to fingerling stage. So I warmly welcome Mr. Indiga to lead the presentation, please.
Hello, you are welcome. My presentation is development of low-cost feed for tilapia Oreochromis niloticus fry to fingerling stage. Supervising Mr. Rajan Sasika Sambat and Mr. W. Langrol. Introduction. Tilapia is the third most important cultured fish group in the world after carps and salmons. And also tilapia is most common food fish in Sri Lanka. It represents 61% from the total freshwater fish production. In addition, NADA is maintaining the hatcheries and rearing ponds for tilapia fish to production, fry and fingering. In addition, mini hatcheries and cages are also rearing tilapia up to fingering for the stocking to many reservoirs as well as pond. Cost of feed become the major input cost for the fish production. The low cost and nutritious diet for the fry to fingering will be helped to enhance their profit and produce healthy fish for farmers. The blood meal is a perfect fish meal replacing the tilapia feeds because they are high protein and essential amino acid profile. In the fish farming, fish feed is critical because it represents 40 to 50% of the production cost. If we can use low-cost ingredient by using the to product fish feed, we can reduce cost of production. It will be help to increase the profit as well as enhance the farmers situation. In the fish feed production, the fish meal is the most expensive protein ingredient. So we can use some cheap ingredients to replace the fish meal. It will be help to develop the fish culture in Sri Lanka. Objectives. There are two objectives, primary objective and secondary objective. Primary objective is to develop a low-cost balanced diet for tilapia fry to fingering stage. The secondary objectives to study effect of development diet on growth performance of tilapia and to assess effect on water quality parameters. Materials and method is first one, location. The experiment was conducted in Carp Breeding Center, Udavalaga. It is belong to National Aquaculture Development Authority. Its short name is NACDA. Materials. During our research period, we use some instrument as a material. Some fiberglass tank, thermometer, pH meter, electronic balance, measuring board, like this. Fish feed preparation. You can see some pictures of how to prepare in fish blood meal and fish feed. There are some you can get some idea referring the these pictures. Experimental design, RCBD, randomized complete block design we use. There are 4 treatments, T1, T2, T3, T4. T4 is used as a control. Others T1, T2, T3. Those treatments we change the blood meal percentage in the fish feed. Replicates. Number of replicates 3. There are 4 no treatments combination. Number of fish per tank in means 1 replicates 150 fry. The slide show what are the formulation we used fish feeds. Treatment 1, treatment 2, treatment 3 and treatment 4. Normally we use normal commercial feed, tilapia fish feed as a controller. The experimental layout. The fish was fed 5% of their body weight in 3 rations throughout the experiment. In addition, the ration was adjusted every week because of their growing and their body weight also increased. So that is why we have to increase fish feed amount. Data collection. Some data we collected like this thing: length, weight, pH, temperature, feed intake, like this, CR and survival rate. Data analysis. Data analysis by use one-way ANOVA. Statistical analysis was performed by using SPSS software. All are known as SPSS software. Result and discussion. This graph show how to length variation in the 4 treatment during the research period, as well as this slide shows how to variation the weight in the 4 treatment during the research period. This bar chart showing the feed utilization. This is the cost analysis. According to slide, you can get some idea how to reduce the percentage fish feed cost in the between 3 treatments. The survival of tilapia. We saw water parameters during the whole research period, the variation of the temperature, pH as well as DO. Conclusion. There are some conclusions. Nine tilapia fingerlings have the capability to utilize blood meal as a protein alternative for fish meal. Second one, therefore, economic profitability can be improved by reducing the fish meal due to its highest value than blood meal in the experimental diet in the terms of cost. This diet allows to obtain raw performance similar to diets containing fish meal. Some recommendations, you can get some idea according to slide, our recommendation. Reference. Thank you very much, all of you. Thank you.
Oh, thank you very much, Indiga. It is a nice presentation for the development of the low-cost feed for the fingerlings, fry fingerlings. Now, this information, what you have found out, how are you going to disseminate to the farmers, those who are going to involve with the aquaculture operation?
So actually, Indiga is not available because he has some signal problems. That's why I joined. Actually, he is working Mr. Indiga. He is working in Negda, and he is working with the farmers, and he is trying to disseminate these findings to farmers. Actually, sir, because the cost is so high in fish culture. That's why trying to this kind of ration. He is trying to, with his institute, to introduce this ration to farmers to reduce their cost of production.
Through NACTA?
Yes.
Okay, that's a very good initiative. I think that many farmers can get benefit as soon as possible. Okay, let us move to the next presentation. Thank you.
Thank you, sir.
So the next presentation is on the production of jackfruit seeds pulp incorporated milk toffees. So I would like to invite Ms. Abhiratna to take us through the presentation, please.
Have a nice day, gentlemen and ladies. My name is MGYK Abhiratna. My topic is development of milk toffees with jackfruit seeds pulp. Introduction. Jackfruit is a species belonging to Canadian produce about 100 to 200 fruits per year. Each fruit contains average of 100 to 500 edible and nutrition seeds. Seeds are highly nutritious but hardly consumed. Therefore, it is important to introduce value-added products to encourage consumption of seeds. Objective: to develop a value-added product using jackfruit seeds, to introduce a home industry as an income-generating avenue. Materials and methods: treatment, seeds pulp, milk powder, sugar, groundnut powder, water. Treatments were tested in Food Research Unit Gunmore in 5 replicates, and the quality of the product was tested using a tasty panel comprised of 30 members. Procedure: when boiled, the failed seeds were made into a pulp. Add a different proportion of pulp, milk powder and other ingredients. Cook at 107 Celsius until reach the correct consistency. Spread the pulp on a tray, garnish with margarine. Cut into squares in desired size to form toffees. Quality of the product was evaluation with the taste panel. Result of sensory evaluation: color, taste, appearance, texture, overall acceptability. Making contents of toffees with different combination. Treatment, moisture, ash, curd protein, egg extract, curd fiber. Conclusions. About 75% seeds pulp can be incorporated without affecting the quality of the milk toffee. It is possible to practice as a cottage level industry. References. Thank you.
Thank you, Ms. Abhay Ratne, for the presentation on the jackfruit and edible toffees. Have you measured the bricks value of this one, the confectionery?
Sir, value in Sri Lanka, bricks value.
Yeah. Did you measure the bricks value of these? No, no? Okay. 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 Thank you very much. Okay. Let us move to the next presenter. So the next presentation is going to be on the effect of newly modified Panchagavya on growth, yield and pest incidence of capsicum annum in open field cultivation. So I would like to invite Mr. Vidutanga to have a good time with us.
Have a good day. My research topic is effect of newly modified Panchagavya for growth, yield and pest incidence on capsicum annum in open field cultivation. Variety Muria 358 F1. Contents are outlined as follows. Introduction, objectives, materials and methods, result and discussion, and references. Introduction. Vegetable cultivation is one of the main income source of upcountry farmers. Capsicum is one of the popular vegetable grown in upcountry. Muria 358 F1 is a recently introduced exotic variety with popularized within short time. One of the main problems associated with capsicum cultivation is heavy use of agrochemicals for pest disease control and to get high yield. Panchagavya, a blend of 5 products obtained from cow. Used in South India from Lone Bank, cow dung, cow urine, milk, curd, ghee. Panchagavya as a fertilizer, as a pesticide. Problem justification. Overuse of chemical fertilizer and pesticide in vegetable cultivation make detrimental impact on human health and environment. Test study has been revealed that Panchagavya can reduce pest incidence while improving plant growth. Here the ordinary Panchagavya preparation used was slightly modified by adding yeast. Therefore, this study was designed to study the effect of newly modified Panchagavya on growth, yield and pest incidence of capsicum annum in open field cultivation. Objectives. The main objective is to identify the effect of newly modified Panchagavya as a pesticide for the capsicum annum in open field cultivation. Specific objective, to identify the effect of newly modified Panchagavya on pest incidence, to identify the effect of newly modified Panchagavya on growth parameters, to identify the effect of newly modified Panchagavya on yield parameters. Materials and methods. Experimental location. The experimental was conducted at Bandarli open field. Experimental design, randomized complete block design with 3 replicate and 25 plants per 1 replicate. Treatments. Treatment 1 water, treatment 2 modified Panchagavya 3% solution, treatment 3 modified Panchagavya 5% solution, treatment 4 neem seed kernel extract. experimental design was like this. Preparation of newly modified Panchagavya. Fresh cow dung 1 kilogram and ghee 142 grams mixed in white mouth plastic barrel, dried and kept in shade for 3 days. Then added 1 liter of cow urine and 1 liter of water to the mixer, kept stirring for 15 days in shade. After 15 days, milk 430 ml, curd 285 ml, tender coconut water 200 ml, jaggery 250 grams, ripe banana 2 numbers and yeast 10 grams. Mixed and stirred intermittently for another 15 days. Preparation of neem seed extract. Well dried 5 kilograms for neem seeds were ground to make fine powder and 1 liter of water was added, kept for overnight after closed. Test plot Muria 358 F1 4 weeks old seedling transplanted in polythene pots. Protein media 3 parts of topsoil, 2 parts of compost, 1 part of half burnt paddy husk. Planting spacing 40 cm 40 cm. Fertilizer application and other management practices done according to the recommendation of Department of Agriculture. Data collection. Following data were collected: number of plant pest attack, count of leaves, count of damaged leaves, plant height and yield. Data analysis. Data were analyzed statically. Result and discussion. Nutrient composition of newly modified Panchagavya is like this. Analyzed by Soil and Plant Laboratory, Tea Research Institute, Talavakali. The result of the research: effect of different treatment on number of leaves, of damaged leaves, plant height and yield. Effect of treatments on number of leaves. In this experiment, 5% newly modified Panchagavya had highest performance on number of leaves of plant in 3 weeks to 8 weeks after planting. This may be due to micro, macro nutrients and plant growth hormones present in newly modified Panchagavya. Effect of different treatments on number of damaged leaves. When comparing number of leaves at 8 weeks with other treatments, 5% newly modified Panchagavya showed better result on pest control. Effects of different treatments on plant height. The highest plant height was recorded in 5% newly modified Panchagavya, followed by 3% newly modified Panchagavya at 8 weeks after planting. That may be due to the growth enzymes present in newly modified Panchagavya. Effect of treatments on plant yield. According to this experiment, this highest yield found the plant treated by 5% newly modified Panchagavya and the lowest yield found from water treated plant. This might be due to the nutrient growth promoting hormones and pest controlling ability included in newly modified Panchagavya. Conclusion: newly modified Panchagavya at 5% concentration increased plant growth and reduced pest damage. Therefore, it can be concluded that newly modified Panchagavya is a good alternative nutrient source and pesticide which can replace certain amount of synthetic chemicals in agriculture. References. Thank you very much.
Okay, thank you very much, Vijayaranga, for a nice presentation. So, what I have seen in the presentations that the 3 or the 5% of the modified Panchagavya have a greater yield. It's not only the 5% because there is statistically by the DMRC there is no difference. So I think either of we can recommend to the farmers anyway. That is not going to be a big difference anyway. So thank you very much, and try to promote the low cost but very effective and environment friendly methods to control the pest in our cropping system in Sri Lanka. Thank you very much. Let us move to the next presenter, please. So the next presentation on the effect of Florax as a seed treatment in the non-fungicidal approach on germination of chili seeds. So I would like to invite Ms. Nishanti to take us through this presentation, please.
Sorry, sir, I couldn't able to share my screen, sir.
Please wait. The sharing option has been now restricted because it's going on the live streaming. Let me ask our IT experts.
Right now it's okay, sir.
Okay, I think Nishanti, you can try now, please.
Yes, sir.
Okay.
Very good afternoon. I am Nishanti Subramaniam. My presentation topic is effect of Chlorex as a seed treatment in non-fungicidal approach on germination of chili seeds. These are the contents of my presentation. The objective is to determine the effect of different concentration of Chlorex solution with different soaking time on germination rate of chili seeds, variety PC1. Let's move into introduction. Chili is one of the mostly widely grown cash crop in Sri Lanka, and also it is the key ingredient in our cuisine. But the problem is cultivation side, late and inconsistent germination. So mainly due to the diseases. The disease causing organisms such as fungi, bacteria, viruses are the main factors for influencing in late germination. Those are airborne and soil-borne pathogens. So to improve germination performance of chili seedlings, seed treatment is normally practiced. Seed treatment is treating the seeds with any substances to improve the germination. Conventionally, we usually use the fungicides, but the thing is the fungicides are very harmful in nature. So there is a necessity to find out the alternative options to improve the germination performance in chili. So in this context, Chlorex would be the alternative best option to treat the chili seeds. Since it has a hypochlorite ion, it has the ability to kill the microbes. Let's move into materials and methods. Experimental location was Microbiology Laboratory, Faculty of Agriculture, Eastern University, Sri Lanka. The preparation of Chlorex solution was done by using sterilized water. The concentrations were maintained 5, 10, 15 and 20%. It was mixed with the sterilized distilled water. The collection of chili seeds were obtained from Seed Sale Center, Eastern University, Sri Lanka. There were 12 treatments including 3 controls. The treatment combinations were mainly based on the different concentration of Chlorex 5, 10, 15, 20 with that different soaking time 20, 30 and 40. For the control treatment by using sterilized water, different time duration was kept 20, 30 and 40. These are the treatments. Experimental design was CRD. There were 3 replicates. To determine the germination performance of chili, the petri dish method was performed. Initially, sterilized petri dish were taken and filter paper was placed on the petri dish, and after that, sterilized water was sprinkled. Then, according to the treatment, treated chili seeds were placed on the petri dish and labeled. It was allowed for 14 days for the observation. Significance of treatment's effect on measured variables were determined by using SAS software, and treatment means were compared using DMRT at 5% significant level. Results and discussion. So this table shows us the effect of different chlorus concentration on number of days taken to germinate 50% of seeds. As per the results, there was significant difference among the treatments. Treatment 3 and treatment 9 shows the lowest number of days to take to attain 50% of seeds germination. So when comparing T3 and T4, there are no significant difference between them, while the treatment 12 took highest number of days to attain 50% of seed germination. This table shows us the effect of different chloride concentration on germination percentage of chili seeds after 14 days of seeding. So according to the results, there were significant difference among the treatments. Treatment 3 and treatment 9 shows the highest percentage of germination in treated chili. It was 70%. Again, there were no significant difference among the treatment 3 and treatment 9, while the treatment 12 shows the lowest germination percentage compared to control. So if we take the option T3 and T9, the T3 concentration was 5% and again T9 the concentration was 40%. So by comparing the concentration of chloride solution, since it is a chemical, it's better we can go for the option T3 in terms of the health and in terms of the cost effectiveness. Why the treated seeds showed the highest performance? Maybe it has because of the hypochlorite ion present in that bleach solution. It inactivates the pathogens available in the seed coat. So we observe T12 treatment unable to perform well because higher time of exposure to the chemical with the seed, it may lose their viability for the germination. So this might be the reason for why the T12 perform low level. So our present findings agreement with the studies of previous researchers in terms of using of chlorates as a seed treatment in different crops. So from this research demonstrated, the conclusion is it could be concluded chloride solution enhanced the germination percentage, number of days taken to germinate 50% in chili seeds. Further, soaking of chili seeds in 5% of chloride solution for 40 minutes would be the feasible and best option to treat chili seeds prior to the field establishment to enhance the seed germination. These are some references I have used to prepare this presentation. Thank you.
Thank you very much, Ms. Nishanti, for your nice presentation. I think for the future experiment, you also can consider the low-cost organic seed treatment materials like Bija Mirda. So it's a kind of an organic preparation that can be used for seed treatments.
Yes, sir.
Many seeds. So then when you do those type of things, that's easy to compare with this one, and that can lead to the sustainable results. So thank you very much. So
thank you,
sir. Presentation. I think we'll go to the next presenter. The next presentation is on the title of some agronomic factors as influenced by the application of cattle and poultry manures along with foliar application of vermi wash in okra.
So I would like to invite Ms. Hiromi Samiraja to present her findings.
Good morning all of you. Today I am going to present about my study on some agronomic factors as influenced by the application of cattle and poultry manures along with foliar application of vermiwash in okra, Abelmoschus esculentus, CVP11. I am DSNM Samiraja. These are the contents of my presentation. The botanical name of okra is Abelmoschus esculentus in family Malvaceae. These are some nutritional values of okra and some okra cultivating areas. These are some importance of okra. Production and productivity of crop adversely affected due to the deficiencies of nutrients, deficiencies due to intensive cropping, loss of topsoil by erosion, loss of nutrients by leaching. This can overcome by foliar application of nutrients and usage of organic low-cost materials. Vermiwash is combination of excretory products and mucus secretion of earthworms. My research objective is to study the agronomic factors that affect the application of cattle and poultry manures in combination with foliar application of vermiwash on growth and yield of okra CVP11. Poultry manure is an efficient organic fertilizer and important source of plant nutrients. Cattle manure is basically made up of digested grass and grain. My experiment was conducted at the Crop Farm Faculty of Agriculture, Eastern University, Sri Lanka, and the experimental design is completely randomized design. Samplings were done at 6 and 7 weeks after planting. This is the layout of my experiment. These are the treatments. These are some cultural practices that I have done. Data were analyzed using SAS 9.4 version statistical software package, and means were compared by using Duncan's multiple range test at 5% level. These are the growth and yield parameters that I have checked. Results and discussion. Maximum number of branches can observed in T5, which is greater than T1 while the minimum from T6. This is due to the presence of macro and micronutrients and plant growth hormones in poultry manure, and fiatin, which is known as naturally occurring cytokinin presence in vermiwash, which enhanced the cell division, resulted in increasing in number of branches. Maximum length of taproot can observed in T5 treatment, which is greater than T1 while the minimum from T6. This is also due to the nitrogen, phosphorus, potassium presence in vermiwash and poultry manure, which stimulates the root growth, and greater absorption, which enhances the root growth. Maximum leaf area index can observe in T5 treatment while the minimum from T6 treatment. This also due to the macro and micronutrients presence in vermiwash and poultry manure leads to enhance the carbon content, water holding capacity, and nutrient availability of the soil. Minimum days for 50% flowering can observe in T5 while the maximum from T6. This also due to the macro and micronutrients presence in vermiwash and poultry manure leads to enhance the soil physical properties. Maximum number of flowers per plant can observe in T5 treatment while the minimum from T6 treatment. This also due to the nitrogen, phosphorus, potassium presence in poultry manure and protease, amylase, and other nitrogen-fixing bacteria such as Acetobacter rhizobium presence in vermiwash. Maximum 100 seed weight can observe from the T5 treatment while the minimum from T6 treatment. This also due to the higher amount of vermiwash and poultry manure, which enhance the nutrient uptake and increase the leaf area index, and enhance the photosynthesis, which would have translocated in the seeds. Maximum economic yield can observe in T5 treatment, which is greater than T1 while the minimum from T6 treatment. This also due to the nitrogen, potassium, zinc presence in vermiwash and easy solubilization effect of poultry manure, which increase the nutrient status of the soil. Therefore, replacing inorganic manures by organic manures such as poultry manure and vermiwash are beneficial. Poultry manure and vermiwash are cheap, eco-friendly and readily available organic manures that improve the soil for continuous cropping and sustainable agriculture. Thank you.
So thank you very much. I think there is a network issue and the presenter is not able to reconnect with us to be on live. So therefore, now from onwards, I would like the session coordinator, Ms. S.A.P. Nelka, to invite Dr. Nisan Salah to continue the session.
Okay, sir. Thank you, Professor Sudarshan, for chairing this session and sharing your knowledge with our symposium. And later part of this session will be chaired by Dr. Nisansala Udanapatirana, Head of the Department of Agrotechnology.
Have a good day to all of you. My name is L.T. Gaishan. Today I am going to present to you germination of Catharanthus rosas seeds as affected.
Okay, thank you, Ms. Nelka. Next presenter is presentation topics is germination of Catharanthus rosea seeds as affected by different seed treatments and growing media. The research done by L.T. Gayashan, S.A.P. Nelka. And the research team, I would like to invite Mr. L.T. Gayashan to present.
Have a good day to all of you. My name is L.T. Gayashan. Today I am going to present to you germination of Catharanthus rosas seeds as affected by different seeds treatments and growing media. This is content of my presentation. Introduction and background of the Catharanthus rosas. Catharanthus rosas is a flowering plant belongs to family Apocynaceae. This plant native to Madagascar but grown elsewhere as an specially ornamental and very specially medicinal plant. This plant is a short white perennial plant. Justification of my research problem. This crop has a high demand, but Sri Lankan growers import hybrid seeds. It's difficult to get high quality second generation from those plant seeds. Therefore, it's better to develop and identify the suitable propagation method for seeds of Catharanthus rosas for mass scale production. Further, this study will support if we are going to improve this plant through biotechnology field such as tissue culture, induced mutation. Literature of my problem justification. Catharanthus rosas is an important floral species in horticulture and is one of the few pharmacological plants that have a long history by Nigme and some others in 2015. And also Catharanthus rosas gave poor growth in different growing media due to very wet, dry or very cold, dry conditions and poor genetic vigor of cultivars by Martin and some others in 2011. Let's go to my objectives. My main objective is to develop an appropriate method for seeds propagation of Catharanthus rosas, and my specific objective is to identify the best seed treatment and best protein media for seeds germination of Catharanthus rosas. Let's go to my methodology. This is a brief sketch of my full research. Catharanthus rosas best seeds propagation method through media types and seeds treatments under shade house condition. This experiment was conducted in a laboratory and research field in UCIARS farmland, and the experiment was conducted
and factorial complete randomized design. This is my research design. 4 seeds treatments, 4 protein media, 16 treatments combination, 4 replications and 10 seeds per replicate. Here are the different seeds treatments I have used, such as first one hot water treatment, second one normal water treatment, third one gibberellic acid treatment, and finally a set of treatments maintained as a control without any treatment. These are the different protein media with different ratios that I have used, such as first one sand only media, second one quadust only media, third one sand plus compost media, and finally sand plus quadust media. Preparation of seed trays. Data was collected as follows and data was analyzed as follows. Research and discussion. Seeds germination is affected by various media. Different media were significantly affected on seed germination of Catharansis roses, but there was no significant effect observed in between growing media and the seeds treatments. Farmers are normally using sand alone media. When compared to the sand alone media, all other media are significantly different, but sand plus compost and sand plus quadust media showed higher germination percentage while they are not significant to each other. Among all types of media, sand plus compost media was selected as the best media by considering its highest germination percentage. Seed germination is affected by different seed treatments. Different seed treatments were not significantly affected on seed germination of Catharansis roses, but highest germination rate is recorded in the gibberellic acid treatment. Its value as a percentage is 86%. Conclusion and recommendation. Sand plus compost 1:1 media is better for germination of Catharansis roses seeds, but used seeds treatments for the study could not significantly under provided conditions. These are my references, and thank you very much for listening to me.
Thank you very much, Mr. Gayashan, for a nice presentation about your research findings. And now presentation is open for the discussion, and I would like to get some comments from the audience also. And I would like to, some participants can ask questions or give any comments about the presentation.
Yeah, thank you very much, Mr. Gayashan. That the seedling in terms of protein mediums. I have one question to ask from you. Then you know that when we germinate the seeds, the temperature is most important factor to be considered. So, did you check the temperature of all compound mediums when you're doing this research?
Actually, Mr. Hasanagar Gayashan is not here because of some network problem. So, hello.
Yeah. Yes.
Each medium, the temperature was measured in each medium.
So that the medium are in ambient temperature conditions, isn't it?
Yes.
Okay, that's why. Thank you much.
Okay, thank you very much. And let's move to the next presentation. Next presenter is Ms. RMAK Manike. Of the research topic is use of banana flour as an alternative thickening agent to corn flour. I would like to invite Ms. Manike to present her valuable findings.
Have a nice day. I'm Mari Manoma Kumarante. My project is banana flour, a thickening agent in cooking. Content. Objectives. To introduce banana flour as a substitute for presently using corn flour as thickening agent in cooking. Materials and methods. There are two treatments. First treatment will mature green banana of variety and wood. Second treatment, corn flour as the control treatment. Treatments were replicated 4 times and observations were statistically analyzed using Wilcoxon ink Randkit test and Puskal-Wallis test. Procedure. Green banana pods were depeeled and sliced. Next, treated with citric acid and dried at 60 centigrade to 60 minutes and ground into fine tar. Corn flour was taken as it was in the market. Next, added to flour to a cup of vegetable soup. Next step, cook to achieve the correct consistency. Next step, evaluated the soup quality parameters using a taste panel. Banana flour, corn flour, soup cup. Performance of banana flour. Parameter. Preparation of flour. Production with green materials. Banana flour 25% to 33%. Corn flour 30 to 40%. Parameter. Amount of flour need to achieve the consistency. Banana flour 12 gram. Corn flour 10 gram. Parameter. Time to heat. Banana flour 1.5 minute. Corn flour 1 minute. Cost in value to product 1 kilogram of thickening material. Total cost is corn flour 800 rupees, banana flour 680 rupees. Comparison of performance between banana flour thickener and corn flour thickener. Summary of sensory evaluation, corn flour and banana flour. To banana flour and corn flour perform equally. In banana flour, undersized fruits can be used, phosphorus losses can be minimized, nutritional value is high, cost is less. Therefore, banana flour would be a thickening agent in cooking. Conclusion. Banana flour can easily be used as a thickening agent in cooking, can be introduced as a cottage level industry. Future suggestions. Favor the of the banana possibility of adding flour. Following agents such as powdered curry leaves, ginger, and garlic should be tasted. For reference, thank you.
Thank you very much for the nice presentation, and it's a valuable initiative for banana value addition. And I would like to raise one question from the presenters, and this is in cottage level actually. In your research is in introducing for a cottage level. What are the suggestions you are having for commercializing in commercial scale for this?
Yes.
Yes, good afternoon, madam. I think we can enrich their nutritional value as adding natural flavoring agents like ginger, cinnamon, cardamom, and curry leaves. Like we can easily introduce commercial level as mainly banana growing area in Sri Lanka.
Okay, before going to that research, did you have any literature search about the usage of this banana flour as a thickening agent?
Yeah, madam. Mainly, there are a lot of research articles usage of banana flour, many purposes. For example, effect of banana flour in growing the boiler performance likewise. But there is no reports about as a banana flour using as a thickening agent. I think this is the normal one.
Okay, then very good initiative. Then we can go for value addition products of banana flour, and we can commercialize this product for future researchers. Thank you very much for the discussion. And next presentation, let's move to the next presentation. Okay, the presenter is Mr. BSR, and the presentation topic is assessment of the effects of different organic fertilizers on growth and production of aloe-barben disease. I would like to invite the presenter to take the presentation.
Glad to meet you all through virtual symposium. Today we are going to see about assessment of the effects of different organic fertilizers on growth and production of aloe-barben disease. Aloe means shining bitter substance in Arabic, while vera means true in Latin. The use of this plant has been known for centuries for its medicinal, skincare, health, beauty and food preservative properties. The Greek scientists considered aloe vera plant as universal remedy. In Sri Lanka, aloe is believed to have been an important part of health and well-being rituals since times of the ancient Ceylonese royals. This is the taxonomical classification of aloe vera plant. As we all know, chemical fertilizer usage increases crop production, but overuse of it pollute the water and air, damage the soil structure, harden the soil, release greenhouse gases, thereby bringing hazards to environment and human health too. Thankfully, organic manures are more effective in aloe vera growth and yield, which is comparable to chemical fertilizer. One of the liquid organic fertilizers is Jeevamrita, which has been used by Indian farmers. Biofertilizer application means inoculation of microorganisms who are capable of converting the non-usable form of nutrient elements to usable form through the biological process. So, our objective is to compare the effects of different organic fertilizers on growth and production of aloe-barben disease. Let's move to methodology. Polybag experiment was conducted by planting 3-month-old aloe vera seedlings from November 2019 to August 2020 in randomized complete block design. The polybag used here is 30 cm in diameter and height. For the preparation of Jeevamrita for 1 acre, these are the ingredients used. It was prepared according to the method described in Fazil et al. 2019. These are the treatment codes and descriptions from T1 to T5. For the fertilizer application, Jeevamrita was applied with 2 weeks interval from first week after transplanting. Compost and cow dung were applied at the rate of 10 ton per hectare as basal application. Commercially available organic liquid fertilizer was applied 3 days, 1 month, 2 months and 3 months after transplanting as per the recommendation to apply EcoGreen Plus. Data measured was statistically analyzed using SAS and the mean comparison within treatments was performed by Duncan multiple range test at 5% significant level.
For the results and discussion, data on parameters were recorded at final harvest at 20 weeks after transplanting. Let's move to the effects of different organic fertilizers on the total leaf area in allobarbendaceae. Here you can see compost is significantly affecting the total leaf area. It may be due to compost increase soil fertility, cell division and cell elongation. Application of compost increase nitrogen use efficiency and restoring soil quality, especially soil biodiversity. Therefore, plant can gain more nutrients compared to other treatments. Same trend was observed by Chowdhury and Hasan-Usman in aloe vera. Compost and cow dung significantly affecting the total gel weight here. It may be due to the application of organics was helped to increase the cell division and elongation without hampering the nutrient uptake process, which was resulted increase in total gel weight. According to Kelly, soil organic matter is a key attribute of soil quality that impacts soil aggregation and accordingly increases water infiltration. Same trend was observed by Pate and Ragib-Usman in aloe vera. Let's move to total leaf fresh weight. Compost is significantly performing better here. Release of nutrients were gradual and slow after mineralization. Such controlled but regulated supply of nutrients increased uptake of nitrogen, phosphorus and potassium, which in turn brought about higher growth and yield. Pate observed that maximum total leaf fresh weight by using compost. So as a conclusion, considering the performances in growth, yield and especially economic important parameter, the compost and cow dung could be recommended for the cultivation of allobarbendaceae in order to enhance the growth and yield which is environmentally friendly for sustainable agriculture. These are my references. Thank you.
Thank you very much for the presenting valuable findings. And author has informed that there is a technical issues and login through this session, and because of that we will move to the next presentation. Okay, next presentation is effect of different seed treatments on germination of okra, and the presenter is Ms. Hunge, and I would like to invite Ms. Hunge to present her valuable findings.
Different seed treatments on germination of okra. This is the topic of our research. As we all know, germination is a critical stage. The early germination and the plant establishment on the field is critical for timely harvesting and marketing the vegetables. Next, the introduction. Okra is an important vegetable crop in Sri Lanka that is belong to family Malvaceae, which has a hard seed coat which delays the seed germination. Normally in the seed germination, water imbibition is the first step. When there is a hard seed coat, it delays the germination. To combat these problems, farmers treated the seeds with different treatment. It may be mechanical, sometimes it may be chemical, or sometimes it may be physical as well. The uneven germination of seed is an issue when planting the okra. Then the farmers are compelled to resow the seeds, which creates more problems in the future. For an instance, when there is an uneven seedling, its fertilizer requirement is different from plant to plant. For some plant, it may be a deficit, for some plant, it may be a surplus, but ultimately it reduces the land productivity. And the okra crops exhibits the seed hardness that prolongs the seed germination, and this seed hardness interferes with seed germination and all other management practices as I mentioned before. Here the MI5, MI7 and Harita are commercial varieties that are recommended by the Department of Agriculture, and for our research we have used this MI7, and the MI5 and Harita have the initial germination percentage of 94 and 93%. The aims of our study. First one is to evaluate the effect of seed treatment on seed germination and plant vigor of MI7 okra variety at the seeding stage. And the next one is to determine the best seed treatment to get the uniform germination and higher vigor index. Generally, the quality seeds with higher germinability and greater vigor index are more important for a better crop stand and the higher yield in the future. Therefore, we use this vigor index as a parameter for our last conclusion. Research methodology. This experiment was conducted in Aquinas College Lab, which was consist of two experiments, as experiment 1 and experiment 2. When considering the experimental design, it was a completely randomized design with 3 replicates and each replicate contained 10 sub-samples. In the experiment 1, as you can see in this picture, we place the treated seeds on the wetted cottons in the plates. And the second experiment, as you can see in this picture, we place the treated seeds in soil in plug trays. In the experiment 1, we calculate the final germination percentage, mean germination time, germination index, first day of germination and last day of germination. And in the experiment 2, we just calculate the seedling vigor index. Then the treatment. Here, the first 4 treatments can be seen in the previous literature, but the 5th one is little bit different because this one. Because I will explain it more details in the coming slides. And here we have used 6 parameters according to the previous literature dated 2005, except this one, that means germination index. All other parameters are prone to misinterpret the result. Therefore, he introduced this germination index parameter is the most accurate parameter to evaluate the germination performance. And as I mentioned earlier, all the 4 treatments that we can see in here are available in the previous literature. But this modified treatment, here we have used 5 hours because we conduct an experiment earlier to find the effective soaking hours after scarification, and it was consist of 2 hours, 5 hours, 12 hours and 16 hours soaking period after scarification. After that, there is significant different we identified in the final germination in 5 hour soaking period when compared with other soaking periods. That's why we use this 5 hour soaking period for our modified treatment. Then we comes to the results. The first thing, final germination percentage. According to the previous literature, this one, T3, 80% sulfuric treatment is the best treatment to get the highest final germination. Similarly, in our studies too, we saw this one. And the least final germination is recorded T1, it's 48 hours soaking. In here, the thing is, dipping the seeds for a longer period like 48 hours, it decreases the germination percentage because it affects the respiration of the seed. The next one. As I mentioned earlier, this final germination percentage does not provide any clear image of the germination speed or the uniformity because it only represents the final germination percentage. And the next one, the final mean germination time. In here, the highest final germination time was recorded in T5, that modified treatment, and the least final mean germination represent T0, that means the control. Normally the mean germination time represent how faster the germination takes place. The next one, the germination index. This is the most mean germination represent, as I told you earlier, because 0, that means the control. Both germination percentage and the speed. Normally the mean germination time represent, you can see how far T5. That means the modified treatment has the highest germination index, even though the T3 has the highest final germination percentage. When come to the germination index, it is low in T3. The next prominent parameter is seedling vigor index. Here also you can see that T5 has the highest seedling vigor index and the least is T1, that means soaking 48 hours. Actually, what's the importance of this seedling vigor index? Seedling vigor index is represent the capability or the vigor of the plant to compete for the basic needs like nutrition, water and sunlight. That is more important. And the next one is the first day and the last day of germination. Here the least first day and the last day of germination represent in the T5 treatment, and normally the first day of germination means the day on which the first germination event occurred, and it represents how faster the germination take, or means that faster germination initiate. And the last day of germination means how faster ending of a particular germination is. Before I move to the conclusion, I would like to remind one thing that I have said earlier. Generally, the quality seeds with higher germinability and a greater vigor index are important for a better crop stand and for a higher yield in the future. Considering the germination index and the vigor of the okra seedling, soaking 5 hours after scarification is the best treatment that eventually eliminate the uneven germination with high capability to compete for the basic needs. And these are the some reference for a study. And this is the end of our presentation, and thank you.
Thank you very much, and it's a very informative presentation and very good findings. And I would like to stress one comment actually that you mentioned about three varieties of okra and harita in MI5 and MI7. What is the, do you find any reason of that? Why it is MI5 is, it's not germinating like MI5 and harita is germinating in 94%, and what is the reason for not germinating like that in MI7? Any reason?
The main reason that the main reason is
Yes, we can hear you.
The main reason we get that MI7 because already they denote that Harita. That is the main reason, but we didn't do any further experiment to identify any specialty within the morphology of that MI7. That is the only reason we take that MI7.
Okay, thank you. And thank you very much. And we will move to the next. I think the session is over now. The session one, all the presentations now over. And we will move to the next technical session number 2. Until then, thank you very much for all the presenters. And thank you.
Yes, thank you, Dr. Nisansala, to sharing this session and dedicating your valuable time with us. Thank you very much.
Okay, ladies and gentlemen, thank you very much. Thank you very much. Session chair for Professor Sudarshan and coordinator for technical session 1, Ms. SAP Nelka, for their contribution. Okay, now we have completed technical session 1. Now we have to start technical session 2. However, our organizing committee has decided to start it after a small break. Then you can join our technical session 2 at 1:30 p.m. after a small break with same Zoom link. Okay, thank you very much. Good evening, ladies and gentlemen. Now we are going to start technical session 2. So I would like to invite Ms. S.L. Navaratna to conduct her technical session. She is the session coordinator for the technical session 2.
Okay, thank you very much, Mr. Asiter. This is now we start in the technical session 2. The theme of the technical session 2 is green agriculture for ecosystem safety. First, I would like to introduce chairperson of this session, Dr. Nisansala Vidanapatirana. She is a senior lecturer in the University of Colombo, Institute for Agrotechnology and Rural Sciences at Hambantota, and head of the Department of Agrotechnology since 2015 up to date. She completed her PhD studies with European Union scholarships in University of Turku, Finland, and she has done her PhD research in Finland in the area of information systems science, especially on e-learning for farmers with collaboration of University of Colombo. She joined to University of Colombo Institute for Agrotechnology and Rural Sciences in year 2007 and able to introduce Bachelor of Agrotechnology degree for farming community as the first ever degree program in Sri Lanka for agriculture entrepreneurs. So I cordially invite you to chair the session, madam.
Okay, thank you very much. This is the technical session 2. Theme of the session is green agriculture for ecosystem safety. And then we will move to the presentations of the technical session 2. First presentation is, we will move to the first presentation. And first presenter is Mr. T.S. Hapuarachi, and the research presentation is study on chemical extraction of fiber from banana pseudostems. Then I would like to invite Mr. T.S. Hapuarachi to present his valuable findings.
Mr. Chairman, ladies and gentlemen, I am Tilak Hapuarachi. I like to share my experience on extraction of fiber from pseudostem of banana, Musa species by chemical means. First, I will give a brief introduction. Banana is the major fruit crop in Sri Lanka and cultivate mainly aiming fruits. But there is a potential to get fiber from stems. Fiber can extract mainly manually and mechanically, but it damages fiber. Quality is poor, time taking, damaged fibers and labor consumption is high. Therefore, it is important to introduce an alternative measure. The objectives are to identify a chemical mean to separate fiber from pseudostems, to identify the most appropriate concentration of the identified chemical, and to introduce this technique as a cottage level industry for banana growers. The study comprises of 2 experiments. Experiment 1 is identification of appropriate chemical extractant for separating fiber. Treatments were sodium hydroxide, potassium permanganate and distilled water as control. It was planned in CRD with 5 replications. The procedure was first separate the sheets and cut into 60 centimeters length, then dip the sheets in different chemical solutions, kept for 2 weeks at the room temperature, taken out from the solution and washed well. Now extracted fiber from remaining and resultant fiber were subjected for quantitative and qualitative observations. If you see the results, the time taken to extract fiber is very long in distilled water. The other parameters are not significant. With potassium permanganate, fibers are purple. Therefore, it is not good. But sodium hydroxide gave shiny white and good looking fiber. So we identified sodium hydroxide as the best extractant. Based on the result, I wanted to identify the most appropriate concentration on sodium hydroxide. So I planned the experiment 2, identification of the most appropriate concentration of the selected chemical. Here 5 concentrators were tested in CRD following the same procedure. Fiber weight is discrete with lower concentration, but the other parameters were not significant. The most important thing was the cost. Considering the lower cost and the environmental health, the lowest concentration was selected because we must dispose the remaining sodium hydroxide. It is not environmentally good. Using these fiber, it is possible to develop products easily. So the conclusions are, sodium hydroxide could be the most appropriate extractant of fiber. Even the lower concentration of sodium hydroxide results fiber in equally good quality. The lowest concentration 1% could be the most suitable concentration with minimum cost and the environmental health, and could be easily introduced as a cottage level industry. Thank you very much for your kind attention.
Thank you very much, Mr. Hapuarachi, and it's a very good findings because for value addition of the banana. And in your presentation, it is highlighted that the sodium hydroxide is the most suitable extraction for the fiber, banana fiber extraction, and 1% is the most suitable. And as a suggestion, I would like to say that you can go below the concentration of 1% and try for another concentration series, because that sodium hydroxide is a waste for the environment. And actually, do you have any plan to continue is there as a commercial level for this?
Yes, madam. Yes, madam. The research is still ongoing, and I am further during the diluting the sodium hydroxide concentration for dispose and neutralize sodium hydroxide chemical. So we can reduce, if not, we can minimize environmental effect and also decrease the cost to neutralize sodium hydroxide. When this stage, I did dilute sodium hydroxide from 5 to 1 concentration. The lowest concentration of 1 of sodium hydroxide that is better for fiber extraction with environmental friendly. Further doing research from 1 to sodium hydroxide, 1% sodium hydroxide concentration to lowest concentration for dispose and neutralize sodium hydroxide.
Yeah, very good. Then we can find some the concentration series, and then we can introduce for the commercialize the technology for fiber extraction further. Thank you very much. And next we will move to the next presentation of the technical session 2, and the presentation is Salvinia molesta, an invasive aquatic plant with potential multi-uses. The presentation is going to do by KG Karpayarachi, and I would like to invite Ms. Karpayarachi to present her valuable findings. I am Kasuni Karpayarachi. This presentation on Salvinia molesta, an invasive aquatic plant with potential multi-uses. Let's move to the presentation. Salvinia is a tree-protein aquatic fern, belongs to the family Salviniaceae, and it originated from the South America and indigenous to the southeastern Brazil. This plant grows best in still or slow-moving water, and it can be easily identified through the floating leaves, which are broadly rounded and green. The upper leaf surface is covered with long, stiff leaf hairs that make the leaf to buoyant. Salvinia spread throughout the tropic and subtropic regions of the world via ornamental plant industry, and since the early 1939 it has spread to the number of water tanks and connected drainage system in Sri Lanka and made a lot of environmental issues, economic and the sociological issues. So it is important to identify the environmental friendly way to control this invasive aquatic plant. Therefore, this presentation summarizes the potential uses of Salvinia to utilize it in productive manner. There are a number of potential uses in Salvinia. First one, it as animal feed, and second one, it as a bioagent for the treating wastewater, and third one, it as a bioindicator for the heavy metal pollutions in the aquatic systems, and fourth one, it as a substrate for the biogas production, and fifth one, it as the material for paper making, and sixth one, material for the organic fertilizer productions, and last one, it for the vermicompost production. Let's see these uses in detailed manner. First one, as an animal feed. This aquatic fern with the high moisture and the bulkiness, so it is made difficult to use in fresh form, but it is practicable to dry under the sunlight in the tropical country. After sun drying, it can be given to the animals as feed. The feed shows a nutritional value comparable in certain respect to the quality forage for the ruminants. Second one, for the treating wastewater. Salvinia has ability to survive and grow when the water is unsuitable for other plants, and hardiness and the high growth rate of this plant make it suitable as a bioagent for the wastewater treatment. Third one, it has a bioindicator because it is a good and special potential to identify the presence of heavy metals in the reservoirs and especially to cadmium pollution in the aquatic ecosystem. And fourth one, it is a substrate for the biogas production. This Salvinia has potential to produce 58.16 liter per kilogram with 54% of methane concentration. And fifth one, as an organic fertilizer. Salvinia can potentially influence the growth of other aquatic plants growing in the same water system because it has higher concentration of indole acetic acid in planting material. Sixth one, it has for the compost production. Here, the Salvinia can be vermicomposted without any pre-composting or any other form of elaborate pre-treatment or any fortification with animal manure by application, the concept called the high rate of vermicomposting. And other than mentioned uses, it can be used as a good material for paper making and packing. This table shows you the research that paper produced using the Salvinia and the rice straw. According to these properties, it is a potential material for the paper making and the packing. Although this plant has number of uses, some constraints restrict the usage. Let's see the constraints. The high content of the fruit dash, lignins and the tannin reduce the acceptance as well as the digestibility, and it restricts the use of Salvinia as a potential feed source for the ruminant. Other than that, high cost associated with the labor and the machinery for processing restrict the usage. Therefore, future research are needed to overcome these problems.
Although this is an invasive aquatic weed, Salvinia molesta can be used in different manner like animal feed, fertilizer, biogas production. So, this invasive aquatic weed can be controlled through the application of alternative uses in beneficial manner. These are the references. Thank you all.
Thank you very much, Ms. Katparachi, for your valuable findings. It is, I think, a literature study, review study, and I would like to stress one comment. Do you find, did you find any literature coming from Sri Lanka for these kind of multi-users in Salvinia?
No, madam. When I am doing the literature search, normally the findings mostly come from the India, Kerala district like areas. In Sri Lanka, up to now, there is no uses in these findings. But this aquatic weed highly spread in the Sri Lanka.
Yes, maybe it is not in literature, but do you have any idea of small scale uses or something like that in Sri Lanka for Salvinia? After removing the Salvinia from the reservoirs, are there any uses or are there any products in a small scale of in Sri Lanka?
I think, madam, in a small scale, they use for the compost production like things, but not used for the other usage I mentioned, like feed material and the paper making, like because it need high machinery process and the machinery techniques, only for the compost production.
Yeah, then it will be used for, it can be used for this Salvinia in invasive weed for multiple uses, and these findings can be used for some kind of research in Sri Lanka also. Okay, thank you very much, and we will move to the next presentation. This is the third presentation in the technical session 2, and introduction of a user-friendly biofood wrapper using Heliconia beehive leaves. The presenter is Miss IC Dodampe, and I would like to invite Miss Dodampe to present her valuable findings in this symposium.
Good morning to you all. I am Ms. Dodampe. My research title is Introduction of a User-Friendly Biofood Wrapper using Heliconia beehive leaves. This is a brief introduction about my study. Polythene sheets are used by the most of the people to food and is commonly collected as lunch sheet, but it is very harmful. It is not biodegradable. Therefore, it is very much important to introduce a possible and suitable biofood wrapper. Banana leaves are commonly used biofood wrapper, and Heliconia beehive leaves are a better substitute for it. But Heliconia leaves are comparatively narrow and it not adequate to used as food wrapper. Hence, it needs to join together. Therefore, an experiment was conducted with the objective of introducing a biofood wrapper with narrow Heliconia leaves. Next, methodology of my study. This experiment was conducted at the University of Colombo Institute for Agrotechnology and Rural Sciences, Lovigatte, Hambantota. Initially, the suckers were collected from Ganmaria, Sri Lanka. These collected suckers were planted in a well-prepared land in the experiment site, and those plants were maintained with optimum management practices. Well-grown, fresh, fully experimented and good-looking leaves were harvested after 4 months of time. Dust and ash the surface of the leaves were removed. Leaves were holding it on hot water for few seconds. Cured leaves were air dried under room temperature for 4 to 5 hours. Midrif of the air dried leaves were carefully removed using a sharp blade. By using different sticking agents, the leaves were attached with thinner paper at the outer surface of the leaves to produce the food wrapper in adequate size. There were 5 treatments and each contained 20 replicators. Different sticking agents such as soda solution, gelatin solution, wheat flour solution and rice starch solution were used as different treatments. A set of treatments was maintained as a control without any sticking agent application. At 2 days interval up to 10 days, food wrapper were undergone for a sensory evaluation using a 20-member panel. The data collected were color status, smell, endurance, and overall acceptability. Collected data were analyzed using Minitab statistical software and Toscaiolis test used to test the significance among the treatment. These are the results of my experiment. There was statistical difference among treatments in smell, adherence, and overall acceptability up to 10 days. Further, color change was significant up to 6 days of time, as same as tested showed significant up to 4 days. The food wrapper produced in all technique can be stored up to 4 days without affecting quality. There was a significant reduction in all parameters of food wrappers development using wheat flour, starch and rice, both than that of in wrappers produced with sugar solution and gelatin solution. Therefore, this reveals that there is no use of applying wheat flour, starch and rice, both of we expected the shelf life more than 4 days. Research confirmed that only sugar and gelatin can maintain the quality of wrapper up to 6 days. However, the wrappers prepared with sugar and gelatin solution reduced in all qualities except adherence. Hence, it showed better adherence up to the 10 days. So, these are conclusion. Sugar and gelatin solution can successfully be used as sticking materials to produce food wrapper from heliconia behind leaves in adequate size. User-friendly food wrapper can be produced with heliconia behind leaves as 2-in-1 for busy consumer. References. Thank you.
Thank you for the nice presentation. And these findings are very valuable because nowadays world are searching for bio food wrappers instead of polythene ply sheets and other materials which are harmful for the environment. Then one comment from your research, and the heliconia, as I understood, heliconia cannot be grown in every places in Sri Lanka. It is, I think, in dry wet zone. It is growing very well. Then how you can go to introduce in dry zone the right heliconia?
Yes, madam. Madam, mainly heliconia mainly grow in the wet zone condition. It's required the shade condition. We can introduce to the dry zone. We can grow heliconia as an intercrop for the banana and papaya cultivation.
Okay. Then with incorporate with banana and or papaya, we can grow in heliconia in dry zone, no? Then the experiment also conducted in dry zone. Then did you observe that any improvement of heliconia growing, such as morphological improvements like wet zone?
We observe some different morphological changes. Leaves, the size mainly affect the compared to the wet zone and the dry zone. The comparatively the without the shade conditions, leaf size less than compared to the wet zone.
Okay. Okay. Thank you very much. And next, we will move to the next presentation.
Thank you.
Okay, this is the fourth presentation of this session, and the topic is allopathetic activity of the residues of common herbaceous weed species in orchards. The presenter is Mr. Sirivardhana, and I would like to invite Mr. Sirivardhana to present his valuable findings to this forum.
Hello everyone, I am going to share findings of my research on allopathic activity of the residues of common herbaceous weed species in orchard. Allopathy defined as any process involving secondary metabolites produced by plants and microbes that influence the growth and development of agriculture and biological system. This influence may be either positive or negative. However, negative impact was commonly recorded in agriculture. Additionally, intraspecific allopathy defined by using a special term, that is autotoxicity or autoallopathy. This phenomena commonly used in agriculture for weed management, insect pest management, as well as conservation of nitrogen in croplands. These four herbaceous weed species, namely Cleon viscosa, Androcarpus paniculata, Oncimum sanctum, and Celosia argentea, are commonly available herbaceous weed species in orchard with allopathic properties. Therefore, objective of my research was to examine the allopathic potential of residues of those four herbaceous weed species on seed germination and seedling growth of radish as indicator plant, same weed species, and other field crops. For that, ground residues of air-dried upper ground part of the four herbaceous weed species was used, as well as seeds of radish, same weed species, and other field crop also were used. Two major experiments were conducted using separately filled pot by different concentration of residue mixtures. These residue mixtures were prepared by incorporating different amount of residue with different amount of sand. In here, 20 radish seeds were planted in each pot at 4 weeks after residue incorporation. In second part of first experiment, same procedure was followed with planting of 10 seeds of each weed species filled with residues of same weed species. In second experiment, I used only residues of Celosia argentea because that residue showed highest inhibition percentage in the previous experiment, and same procedure was followed by using 20 seeds of paddy, finger millet, mung bean, black gram, and cowpea. These are the various followed in my experiment, and these are the activities what I done in each experiment. Seed germination and growth data were collected from each experiment, and finally inhibition percentage was calculated using this equation, and experimental design was completely randomized design with 3 replicates. Then results and discussion. In here we can see inhibitory effect of seed germination percentage of radish by different herbaceous weed residues. Celosia argentea show significantly highest seed germination inhibition at all concentrations except 1% concentration, while Andrographis paniculata 1% concentration show some sort of promotion of seed germination. Here we can see inhibitory effect of residues of herbaceous weed species on shoot growth of radish seedlings. All concentration of Clion viscosa show significantly highest inhibition of shoot growth of radish seedlings, while Andrographis paniculata and Oncimum sanctum showing significantly promotion of shoot growth of radish seedlings, and others are not significantly different with each treatment. In here we can see root inhibition of radish seedlings. Here also Andrographis paniculata 2.5% concentration show some sort of promotion of root length, while other concentration showing inhibition of root length, and Clion viscosa 10% show highest inhibition of root length. This graph emphasizes effect of different concentration of each residues on number of leaves per seedlings of radish. Most of the concentration of all weed species show promotory effect of number of leaves per plant also. In here also we can see these residues act as a promoter for dry weight of radish seedlings. This may be happen due to the supplying of nutrient from decomposing residues of each weed species. Here we can see how different concentration of different residues may affect on seedling growth of radish. This graph we can see how residues of each species may affect their seed germination. Here also 5 and 10% concentration, so 100% inhibition of seed germination of same weed species. Here we can see growth of germinated seeds of each weed species has been promoted by the residues of each weed species. Here we can see strong correlation between Celosia argentea residue concentration and seed germination percentage of field crop including paddy, finger millet, black ground and millbean. Here highest concentration 10 and 15% 100% inhibited seed germination of those field crop. And therefore we can conclude our results. Those 4 herbaceous weed species would be able to inhibit seed germination and seedling growth of radish and same weed species, and also Celosia argentea residues may badly affect on succeeding field crop. As well as this phenomena can be used to manage weeds in orchard also. These are the references, and thank you.
Okay, thank you, Mr. Srivardhana, and for your valuable findings. And I would like to ask a small comment from you. Do you have any idea about that allelopathic effect? Is it always negative effect or any positive side?
Yes, madam. In agriculture context, it is some sort of negative effect can be identified. However, during my research, I identified there is a positive effect also. It means some residue concentrations what I used for my research has been increased seedling dry weight as well as seedling number of leaves per seedlings in radish. Therefore, we can think this phenomena is not only negative, there is a positive effect. This research was conducted as a part of development of an eco-friendly weed management method for papaya orchard. There I used these 4 weed species as a cover crop to manage other weeds in papaya orchard. So I identified Celosia argentea, if it show highly allelopathic effect, however, it can be used mainly for weed management in other managed to other weeds in papaya orchard.
Yes, okay. Thank you very much, Mr. Vardhana, and thank you. And we will move to the next presentation. Okay, this is the fifth presentation of the session, and the topic is effect of seaweed liquid extract application on flowering of roses. The presenter is Ms. Kularatna. I would like to invite Ms. Kularatna to present her findings.
Good morning, my dear sir, madam. Today I am going to present my research presentation. My topic is effect of seaweed perennial species liquid extract foliar applications on the flowering of roses. This is contained in introduction. I use roses as my experimental plant. It is one of the temperate cut flower exported in Sri Lanka. Then I have used perennial species for the seaweed liquid extract preparation. It is the one of the brown algae and it consists of micro and macroelement for plant growth. Research objectives are to find the effectiveness and the optimum concentration of seaweed perennial species on the growth and flowering of roses. Materials and method. Experimental site is Crop Farm, Faculty of Agriculture, Eastern University, Sri Lanka. Duration of experiment is July to September in 2020 and I have used completely randomized design with tender application. For preparation, both diameter and height 30 cm pots were filled with compost and red soil corridors in same proportion. Then I have used budded rose plant very local that obtained from the private nursery as planting material. Then I have pruned to get uniform size. After pruning, I have applied Osmocote 5 gram per plant as fertilizer. Then I have irrigate once a day in my research period. These are the treatment. I have these 4 treatments. Treatment 1 is the once a week application of 10% seaweed liquid extract. Treatment 2 is a once a week application of 20% seaweed liquid extract. Treatment 3 is a once a week application of 30% seaweed liquid extract and treatment 4 is a control. This is the experimental arrangement of rose plant and experimental design. This is the preparation procedure of seaweed liquid extract perennial species according to the Sudarshan et al. 2014. I have used destructive method for the sampling method and I have done the month-on-month sampling. I have taken 4 measurements as plant height, leaf area, plant biomass and number of flowers. Then I have done data analysis through the ANOVA by SAS software and I have used Duncan multiple range test for the mean separation procedure. Result and discussion. Plant height. Significantly highest plant height was observed in treatment 2. It agreed with Mandara et al. 2017 in soybean plant and it also agreed with Sudarshan et al. 2014 in maize plant because seaweed contain growth hormones which effective in enhance the rose plant growth. Therefore, treatment 2, 20% seaweed liquid extract is the optimum concentration for the rose plant growth. In treatment 1, it performed lowest plant height. It agreed with Srinivasan et al. 2010 in pigeon pea plant. It could be the suboptimum concentration for the rose plant growth. In treatment 3, it is the once a week application of 30% seaweed liquid extract. It performed lowest plant height. It agreed with Sumangala et al. 2019 in rose plant which used the Sargassum crassifolium seaweed liquid extract. In treatment 4, it performed lowest plant height because seaweed contain plant growth hormones, micro and macro elements which enhance the plant growth. Leaf area. Significantly highest leaf area was observed in treatment 2. It agreed with Sri Krishna et al. 2018 in anthurium plant because seaweed contain polysaccharide like alginate which act as the metal ion chelators that have the ability to bind the micronutrients which enhance the plant growth. In In treatment 1, it performed lowest leaf area. It agreed with Sudarshan et al. 2014 in tomato plant. In treatment 3, it performed lowest leaf area. It agreed with Sodape et al. 2010 in grain gram plant. Because seaweed, with the increasing of concentration of seaweed, performed lowest performance. In treatment 4, it is a control that performed lowest leaf area. Plant biomass. Significantly highest plant biomass was observed in treatment 2. It agreed with Jyotirang et al. 2009 in okra plant because seaweed contains polyphenols which act as antioxidants which enhance the rose plant growth. In treatment 1, it performed lowest plant biomass. It agreed with Ramna et al. 2011 in clustered bean plant. In treatment 3, it performed lowest plant biomass. It agreed with Kalevanan et al. 2012 in Vigna mungo plant. In treatment 4, it performed lowest plant biomass. Number of flowers. Significantly highest number of flowers was observed in treatment 2, which applied once a week application of 20% seaweed liquid extract. It agreed with Kalevani et al. 2019 in Vigna ubiculata plant because seaweed contains betaines which act as a nitrogen source that reduce the diminution of chlorophylls and enhance the yield of rose plant. In treatment 1, it performed lowest number of flowers. It agreed with Thirumaran et al. 2009 in cluster bean plant because seaweed contain growth hormones. Their stimulatory effect is effective in optimum concentration. In treatment 3, it performed lowest number of flowers. It agreed with Luan et al. 2019 in sunflower plant because increasing concentration of seaweed contain high salt index that affect negatively for rose plant growth and flowering. In treatment 4, it performed lowest number of flowers because except control, seaweed contains not only plant growth hormones but also amino acid, vitamins and macro elements which enhance the rose plant growth. Conclusion. Roses are grown in 20% seaweed liquid extract. Perform optimum concentration to increase the growth and flowering in roses and perform better performance in plant height, leaf area, plant biomass and number of flowers. Flower receives suboptimum and higher concentration at 10% and 30% seaweed liquid extract respectively. It could be the reasons for the lowest performance at this treatment. These are the findings of our research. These are the references. Thank you very much.
Thank you, Ms. Ratna, for your valuable findings presenting in our symposium. And one clarification about that seaweed liquid extraction. And did you observe any negative that kind of effect for application of this liquid extract?
No, madam. I observed 20% seaweed liquid extract is optimum for the rose plant growth, and 30%, that means higher concentration, is not suitable for the rose plant growth because there is a high salt index with increasing of the concentration, because high salt index that increase the salinity of the soil and it causes to upsurge the saline salt index in the plant cells.
And also 20% is the best concentration.
Yes, madam.
Okay. And after flowering, you are not going to apply, no?
I applied, madam, and I measured plant growth also.
Is it possible to apply after flowering also?
Yes, madam. I get applied 3 months for my reading. Take a reading.
Okay. You applied after flowering also, this, no? Then there is no harm for the flowers.
No, madam. Okay. And flower quality also increase. Number of flowers, weight of the flowers, dry matter, like that.
Okay, thank you very much, and nice presentation.
Thank you, madam.
Okay, then let's move to the next presentation. Okay, the presentation topic is potential neglected ornamental species for possible developments in Sri Lanka. And presenter is Ms. Anuruddhi. And I would like to invite Ms. Anuruddhi to present her valuable findings to our forum.
Welcome to my presentation on potential neglected ornamental species for possible developments in Sri Lanka. Moving into the introduction, Sri Lanka owns a high genetic diversity of flowering plants. Among them, most of the species fall under underutilized flowering plants. Floriculture industry in Sri Lanka plays a significant role in the Sri Lankan agriculture sector. But still, we depend on some specific available varieties for our product assortment. Limitation in the product assortment is a major barrier in developing the export-oriented floriculture sector. Therefore, exploring new species while developing new cultivars is required to achieve a better success in the market competition. When think about new species, underutilized crops come to the picture. Underutilized crops are unused commodities which are partially or fully domesticated, while some are totally unevaluated, but still plays a major role in the lives of rural people. Moving into the first species, blue mist or ironwood, in Sinhala we say Korakaha, is an endangered species in Sri Lanka. This plant carries bright blue color flowers in young tree branches. This crop is a potential potted plant when developed to a dwarf structure, and also it is a potential landscape plant. Glory lily or Gloriosa superba is the least concerned crop in Sri Lanka. The plant is cultivated as a garden ornamental in tropical regions, also can be found in forests, grasslands and abandoned cultivated areas. It bears glamorous yellow and red colored solitary flowers. This crop is identified as an emerging cut flower species in Sri Lanka. Color of the flower is possible to be changed through pollination, and it is possible to develop as a potted ornamental plant with a dwarf structure and bright colored flowers. Binara is a near-threatened crop species found in red zone India island. Binara carries blue colored flowers with yellow anthers and is possible to develop to a potted plant. Neelkataralu is the least concerned leguminous crop in Sri Lanka. This crop has attractive natural deep blue colored flowers. The vine can be developed to have less number of leaves, reducing the height. Also, flower color can be changed to deep violet, light pink and velvety blue colors. Mahabovitia or Spicia aspera is the least concerned crop found in open places and along the roadsides in Sri Lanka. Spicia aspera has free flowering nature with contrasting flower color against its foliage. This ornamental flowering shrub has a high potential in the Sri Lankan floricultural industry to be introduced as a potted ornamental plant. Foxtail orchid is an endangered epiphyte in Sri Lanka. It carries a pendant-like inflorescence and has unusual color range. Developing the peduncle with different colored inflorescences will increase the floriculture value of the plant. Vanaraja is an endangered orchid found in Sri Lanka. The leaves are attractive due to its silvery vein patterns. So, this crop is a potential ornamental pot plant. Daffodil orchid. It is an endangered ornamental species in Sri Lanka. The plant has large bright yellow flowers and is possible to introduce as a potted ornamental species. Since the plant do not bear leaves during the flowering season, it may be very attractive if developed as a potted ornamental plant. Therefore, it can be concluded that above-mentioned underutilized floriculture species are capable of developing as new cultivars through breeding programs targeting the flower color, flower size, fragrance of the flowers, leaf size and number, and plant structure. After developing into new species, they can be commercialized as potted ornamental plants. Thank you.
Thank you, Ms. Andruti. It's valuable presentation, nice presentation, and I hope this study open avenue for selecting some wild attractive flowers to develop as ornamental plants in Sri Lanka. We observe a lot of flowering species not utilized in Sri Lanka as ornamental plants and going for the improvements. Okay, one comment, one clarification from you. I observed that in the leaf, you mentioned about the glory lily. We call that as a poisonous plant in Sri Lanka. Why you select this plant is also as a developed as a ornamental plant?
Madam, though it is said that it has some toxic chemicals, it has found that it also has some medicinal values due to the alkaloids present in the plant. Also, I think despite the fact that the plant is poisonous, we have to see the beauty of the plant, and also we have to acknowledge people in which parts of the plant is poisonous and not. So even today, Glorious superba is exported from Sri Lanka for pharmaceutical industries, and also the seeds and the tubers also are exported in fresh and dry forms or as powder or oil. So I think we have to acknowledge people about the poison, in which parts the poison carries and like that. So we have to, this is a potential plant which has a beautiful flower, so we have to see the beauty of the plant, I think, rather than thinking of these poisonous type.
Okay, thank you very much, Ms. Andruti. We will do the next speaker.
This presentation on present status and future scope of floriculture industry in southern province Sri Lanka. The content as follows. Let's move to the presentation. Floriculture industry is considered as a popular agribusiness for decades in Sri Lanka, and it is a good income source and a way of women empowerment. In 2018, Sri Lanka was able to earn $12.94 by exporting floricultural products. Western, Northwestern and the Central Province are the major floriculture production regions in the country, while Southern Province was identified as a possible area for expansion of the floriculture industry. But lack of adequate literature and the information on the present situation about the floriculture industry restrict expansion. Therefore, this study was designed to identify the present situation, constraints and the future potentials of floriculture industry in Southern Province, Sri Lanka. The main objective of this study to identify the present situation and the future scope of floriculture industry in Southern Province, Sri Lanka. There were three specific objectives. First one, to identify the methods of input material supply, type of products and the marketing details of floriculture industry in Southern Province. Second one, to identify the potentials and willingnesses to expand the cultivation of Southern Province. Third one, to identify the constraints to expand the cultivation in Southern Province. Let's see the methodology. 70 flower growers in Southern Province were purposely selected through the different divisional secretariat division in Galle, Matara and the Hambantota district. Pre-tested questionnaire survey was carried out to collect information from the selected flower growers during August to November in 2019, and that collected data were statistically analyzed using Mintab statistical software. Let's see the results here. Overview of the sample growers. In age level, you can see here 50% of them were in the age level between 46 to 55 years and 99% of them were women, females, and the generally unemployed women or women after retirement. Their jobs have engaged with the industry. In education, you can see here none of them were in the no-school education category and 54% of growers were educated up to O levels. In income, 54% of growers were able to earn monthly income more than the 10,000 rupees. Information about the current cultivation. In planting material, growers have maintained mother plants stock to collect planting material. Here 90% of the mother plants are collected from the local farms while some of them were collected from the exporters. In fertilizer application, 59% of growers use combination of chemicals and the organic fertilizer to their cultivation. In pesticide application, 82% of growers apply chemical to control pest in their cultivations. In labor cost, you can see in the graph, 95% of growers use their family members as the laborers while rarely use the hired laborers. And in cultivation, 79% of growers establish shade house, and people who have engaged more than 10 years in the floriculture industry are the owners of the more than one shade house. Here you can see the key products. Both flowering and the foliage plants were sold as potted plant to the consumer. Let's see marketing and the demand. 49% of products sold in the exhibition or directly to the consumer as the marketing method. When we are asking about the demand of the floriculture products in the area, all the growers has been stated that there is a sufficient demand for the floriculture products in the southern province Sri Lanka. And when we are asking about the willingness and potential towards the expansion of the cultivation, the people have expressed their positive willingness towards the expansion of the cultivation. Especially significant number of growers has expressed their positive willingness to invest the large scale to get the improved planting material, to get the financial subsidies, and to improve the production quality, and to participate in the workshop and extension programs. In addition to that, when we ask about the government and the private sector involvement, the significant number of growers, here 81% of the growers express the insufficiency of the government sector involvement, and 84% of growers mention there is the insufficient involvement of the private sector. And when we ask about the constraints of expand the cultivation, 74% of growers mention the main constraint is financial problem, while 11%, 10%, 2% respectively mention the bad climatic condition, infrastructure, and the technical problems as the constraint to expand the cultivation. The floriculture industry in the southern province has huge potential to improve towards export market. Therefore, establishment of the programs to improve the industry using both government and private sector involvement and facilitate the financial support and inputs and establish proper marketing place will be useful in the enhancement of the industry. And these are the references. Thank you all.
Thank you, Ms. Katapayarach, for nice presentation, and it will give the overview of the flowering floriculture industry in southern region and what are the constraints, and do you have any your own suggestion? These are the suggestions given by the farmers and the growers, and do you have any your own suggestion how the southern province or the southern region people can improve the floriculture industry? their own industry?
Yeah, madam. In southern province, mainly my suggestions normally in southern province they establish societies to within 30 or 50 flower growers together. They make societies, flower grower societies. That flower grower society support to develop that industry. But when I am searching about the present situation, I got to know about they plan the exhibition to sold their products. That's the best way to sold their products in southern province, but they don't have proper market in place to sell their products. Normally to sold their product they need that market in place near to the consumers, but they I think they are waiting for longer period to normally rent the proper market in place. Therefore, if we can establish proper market in place for the floriculture industry in southern province, I think it will be beneficial to uplift the industry in the area.
Yes, okay. Thank you very much for your valuable suggestions. And then we will move to the next presentation. The topic is use of eco-friendly technologies to reduce chemical fertilizer usage in paddy farming in Sri Lanka. A study on economic perspective of dry zone paddy farmers. The presenter is Ms. A.P. Silva, and I would like to invite Ms. Silva to present her valuable findings to this forum.
Ladies and gentlemen, I'm Prabha Silva from Vaibhav University of Sri Lanka, presenting you the findings of my research study on the use of eco-friendly technologies to reduce chemical fertilizer usage in paddy farming in Sri Lanka in the form of a study on economic perspectives of dry zone paddy farmers. It has been identified in previous literature that the long-term usage of chemical fertilizer in paddy farming has caused many health and environmental issues. As a solution, National Research Council has launched a project funding to develop eco-friendly technologies, also known as EFTs, under the supervision of university academics. The EFTs subjected to my study are a product package consisting of biochar and biofertilizer. The research aims to identify the perception of paddy farmers who are currently registered with the EFT project on incentives categorized as price, service, materials, and other in an economic perspective. When initiating the research, first the economic incentives that could be implemented if farmers are willing to switch from chemical fertilizers to EFTs were identified. Then, for the purpose of surveying, an in-depth semi-structured questionnaire was developed, including 28 statements on economic incentives. 100 farmers from Anuradhapura and Kurunegala who are registered with the EFT project were selected as the sample, and data were collected via face-to-face interviews. The statements were assessed against a 10-point Likert scale in the form of importance given to each situation. Then, the collected data were coded and analyzed using SPSS software. It resulted in classification obtained through exploratory factor analysis and the ranking and ordering of preferences of farmers regarding the economic incentives. The exploratory factor analysis was employed to test scale reliability, unidimensionality, and validity of the data as well. The majority of the sample were males and they were between 35 to 65 years. About 2/3 of them have had more than 20 years of experience in paddy farming, whereas 40% of them has had education up to JCE ordinary level. Most of the farmers owned less than 2 acres of land. The statements were classified into 4 categories by the exploratory factor analysis as price, service, material, and other factors of economic incentives. According to the aggregated mean importance scores obtained, they had highest concerns regarding the price-related economic incentives and least importance was given to the service-related economic incentives. But if taken statement-wise, they have placed reducing price volatility, information on market pricing conditions and adjusting supply and demand as very important under price category, and equal importance was given to subsidy given in the form of fertilizer for EFTs and laws regarding material disposal under service category. However, the least importance was given to subsidy of chemical fertilizers, capacity building and supply chain management, which come under service category. In conclusion, it can be mentioned that the farmers had higher concerns on financial aspects to adopt eco-friendly technologies given that they have to undergo a high risk in trying to convert the whole system from using chemical fertilizers to eco-friendly technologies. But under proper institutional framework, end users can be given with beneficial economic incentives with the participation of both private and government sectors. Stable economic incentive schemes can promote and regulate the eco-friendly technologies and avoid policy failures. Here are the sources for further reference. The authors would like to thank the National Research Council of Sri Lanka for the financial assistance and all the respondents for their time and experience sharing. Thank you all for your time and attention.
Thank you very much, Ms. Silva, for your valuable presentation. And this is a survey research and about the eco-friendly applications of paddy farmers. And I would like to ask a little comment from you. In your suggestion, in your idea, that what is the main constraint faced by the farmers not going for the eco-friendly applications in paddy farming? What is the major constraints?
The major constraint, as I identified, is that, madam, they have been using the chemical fertilizers for over 30 to 40 years. So they are used to the yield that they are getting from that from those fertilizers. But the constraint is that they have a very less knowledge on these eco-friendly technologies unless that we give them the things that they need to know. So they are reluctant to adopt to these eco-friendly technologies given that it is a huge risk that they are taking by changing their whole system. So the lack of knowledge is the major constraint that I identified through the research.
Okay, thank you very much, Ms. Silva. And this was the last presentation in technical session 2. And thank you very much for all presenters who joined in the technical session 2. And I would like to conclude the technical session 2.
Okay, this is the end of the session, and congratulations all the presenters. I would like to thanks to Dr. Nisansala Pathiran to spend her valuable time with us and sharing her knowledge with us. Thank you very much, madam.
Okay, thank you very much, Session Chair, Dr. N.P. Vidanapatirana, and Coordinator for Technical Session 2, Ms. S.L. Navaratna, for their contribution. Okay, now we have completed Technical Session 2, and now we are going to start Technical Session 3. So I would like to invite Mr. T.G.B. Danushka to conduct her Technical Session. He is the Session Coordinator for Technical Session 3.
Yes, thank you very much, Mr. Rasika. Now it is the time to start technical session number 3. Then let me please introduce the chair of the session. The chairperson is Mr. Hasanaka Rohanadira. He is the graduate of University of Ruhuna, and he got his postgraduate degree from University of Barcelona, Spain. And he he is the head of the tissue culture production facility at UCIARS. He has 13 years of experiences as a researcher and conducted represented national and international level researchers. Then he has already developed many tissue culture production protocols for especially fruits and ornamentals. Then I cordially invite to Mr. Hasanagaro Nadira to chair this session. Sir, could you please chair on this session? Thank you.
Okay, good afternoon, all of you. Thank you, Mr. Damushkar. You all are welcome to the technical session 3. The session theme is ensuring the adoption of sustainable innovations. There are 5 presenters are willing to share their findings with the symposium. Let's go to the first topic. Okay, the preliminary study on microbiological quality of processed spice in retail packs manufactured by selected small and medium entrepreneurs. So I would like to invite the presenter, Ms. Jayawardena. President Jayawardena, to deliver your presentation.
My topic is a preliminary study on microbiological quality of processed spices in retail packs manufactured by selected small and medium entrepreneurs. Authors are TMDA Jayawardena, myself, and DMWD Divisekara. Introduction. Spices are important as ingredients or additives in Sri Lankan cuisine. It provides characteristic flavor and aroma for food. Most of the spices are taken from plant parts. It contributes 9% to gross domestic products in economy. Spice production has an increase in demand in export market too. SMEs are mainly involving in spice cultivation and production. Objectives: to evaluate the microbiological quality of spices manufactured by selected SMEs and to check whether the results are complied with microbiological requirements specified in the Sri Lanka standards. Methodology: samples. Samples were curry powder, chili pieces, pepper powder and turmeric powder manufactured by 10 selected SMEs. For curry powder SLS 134 2017, for chili SLS 1563 2017, pepper SLS 1372 2009 and for turmeric SLS 613 2017 were followed. For microbiological analysis, total plate count, yeast and mold, E. coli, salmonella tests were conducted. The results of total plate count and yeast and mold were recorded coliform unit per gram in log form. For E. coli, most probable number per gram. For salmonella as presence or absent. The aflatoxins were conducted for chili products. Results. The table 1 shows microbiological quality of spice samples. The table 1 continuation. Again the table 1 continuation. All the microbiological results shows that most of the spices samples were not complied to particular standard requirements of SLS standards. The table 2 shows aflatoxin content of chili samples. The SME 8 owning chili powder and chili pieces were detected with aflatoxin. This table shows SLS requirements for spices. Curry powder SME 3 was complied. For meat curry powder SME 2, 5, 6 were complied. For chili powder SME 5 was complied but SME 8 was detected with aflatoxins. For chili pieces SME 8 was not complied and detected with aflatoxins. For pepper powder SME 10 was not complied to the standard. For turmeric powder SME 10, 3 and 9 all the SMEs were not complied to the standard. Conclusion: most of the tested products were microbiologically unstable. Presence of excessive molds leads to aflatoxin production. Actually, aflatoxin is a neurotoxin. Aflatoxins cause potential health threats for consumers. Therefore, good agricultural practices and good manufacturing practices should be followed during cultivation and processing. For the further confirmation, comprehensive studies on microbiological quality evaluation of spices should be done in future. These are the references, a few references. Acknowledgement. Dr. Mrs. Ilmi Hewa Julige, Additional Director General R&D and Senior Deputy Director covering, Ms. Madara Samaranayaka, Research Scientist, and all staff of Food Technology Section of Industrial Technology Institute are greatly acknowledged. Thank you.
Okay, thank you very much, Mr. Jayavardhana, for sharing your findings with us. I have two clarifications to take from you. The thing is, why you select small and medium scale producers instead of the large scale producers? Because if you select the large scale producer, it may some considerable effect for this. This is my idea. What do you think? Ms. Jayavardhana, are you online? Facing some technical issues. Just maybe wait a minute. Let's see. Ms. Jayavardhana. Okay, Mr. Ajay, there's a problem in the Zoom connection. So anyway, shall we move to the next topic? Yeah, the second topic is leaf morphology variation of Maria paniculata. The presenter is Madhushani. So I would like to invite Ms. Madhushani to deliver the presentation.
I'm Chatrika Madhushani. Research title is Morphological Variations in Leaves of Murraya paniculata. This is content of my presentation. Introduction. Morphological characterization is the study of the structure and form development of plant. Phenotype is a combination of both genetic and environment. One genotype can produce more than one phenotype under the environmental factor variability, commonly called as phenotypic plasticity. Genetic diversity of germplasm serves as an important source of information for researchers and botanists. Objectives: to explore the ecogeographical diversity of Murraya paniculata, to characterize the leaf morphological aspects of Murraya paniculata. Framework and methodology. Ecogeographical survey was conducted to identify plant available location which represented all the three agroecological zones in Sri Lanka. Snowball sampling techniques was used as sampling techniques. After visited location, on-site characterization was completed using created plant descriptor for Murraya paniculata. Qualitative and also quantitative characteristics were observed. As qualitative characteristics, leaf arrangement, leaf base, leaf tips, leaf margin and leaf shapes were observed. Under the quantitative characteristics, leaf length, leaf-width ratio, petiole length were observed. Totally 149 acquisitions were observed, covered 11 districts in Sri Lanka. Descriptive analysis and correlation analysis were used. Results and discussion. Variation of leaf qualitative characters with
Agroecological zones. Leaf arrangement varied, alternate, sub-opposite and alternative to sub-opposite leaf arrangement. Mainly alternate leaf arrangement can be observed all the three agroecological zones in Sri Lanka. Mainly a sub-opposite leaf arrangement can be observed with zone in Sri Lanka. Leaf shapes varied ovate, elliptical, oval, body-oval, lanceolate, obcordate to cunate and rhomboid. Leaf apex acute, reduced, rounded, long accumulate, gradual accumulate, narrowly accumulate, obcordate and obtuse. Leaf base varied, acute, rounded, oblique and cunate. These are the summary of the qualitative and quantitative characteristics of Murraya paniculata. Leaf arrangement mainly alternate leaf arrangement observed mainly Polonnaruwa, Galle, Kandy and Kurunegala district. Kalitara alternative to sub-opposite leaf arrangement. Colombo alternative to sub-opposite leaf arrangement. Leaf shapes in Polonnaruwa district rounded and obovate. Kalitara elliptical to obovate. Colombo lanceolate. Galle lanceolate to oblanceolate. Kandy lanceolate to obovate and Kurunegala obovate and oblong. Leaf affects obtuse to subobtuse. In Polonnaruwa district, Kalitara acute, Colombo acute and subobtuse, Galle acute to subacute, Kandy obtuse to subobtuse and Kurunegala obovate and oblong. Leaf base in Polonnaruwa acute rounded, Kalitara acute to oblique, Colombo acute and cunate, Galle acute and rounded, Kandy acute and rounded, Kurunegala acute. These are the few images of variations of leaf arrangement and leaf shapes, alternate and sub-opposite. Leaf shapes, oval, elliptical to ovate, lanceolate and rhomboid. These are the variation of leaf base and leaf tips. These are the location-specific variations of leaf characteristics of Murraya paniculata. Correlation between selected quantitative characters according to the Pearson correlation coefficient. Leaf length positively correlated with leaf width 0.782. Leaf width positively correlated with PTO length 0.438 and leaf width negatively correlated with leaf width ratio 0.318. Conclusion: a remarkable morphological variation could be observed in accessions collected from different agroecological regions in Sri Lanka. This variation could be advantageous for breeders and botanists and floriculturists. References. And this is end of my presentation. Thank you very much for your kind attention.
Okay, thank you very much, Ms. Madhushani, for your detailed presentation and findings. One thing I want to raise from you that you know that you have mentioned that you have selected some plants from the Kandy. So, and I think you have bring them all and establish in UCIARS research plan. So, that Kandy and the Hambantota has some deviated environmental condition. So, did you see that the collected plants from Kandy show the same morphological characters in Hambantota area same? Because sometimes that the temperature and other environmental factor could make that morphological variation, but it's very rare to go past the genotypical variation. So such kind of deviation or the same thing have you seen in Hambantota and also the Kandy for the considering the same variety?
There is the huge gap of environmental condition is the wet zone and the dry zone, the mainly average annual temperature, light intensity. Likewise, actually it is difficult to identify same morphological characters under the establishment field. Actually, phenotypic plasticity, the plant morphological characters are response to the unique environmental condition. It is the 100% morphological characters does not observe in our university establishment field, but The few characters are we can observe. Not only we observe the leaf characteristic, we also observe some floral characteristics. Some few floral characteristics we observe the same morphological characters observed in university, the establishment field, but the large proportion we can't observe. We couldn't observe these morphological the same morphological characters, and even under the identically growing condition, then the difference having a genetic base. The combination of genetic and plasticity response, where the level of the plasticity response is genetically we can determine.
Okay, Ms. Pradeshani, thank you very much for a nice discussion part. Shall we go? Yeah, okay. Let's move to the next presentation. The presentation number 3, the title is Effect of Irrigation Water Management Practices on the Performance of Black Gram. The presenter is Ms. Jalini. So I would like to invite Ms. Jalini to deliver the presentation.
Good morning everyone. Today I am going to present my undergraduate research. Title of my research is Effect of Irrigation Water Management on the Performance of Gram. Contents of my research. Introduction. First we see our introduction part. Water is previous for life on the earth. Without water we cannot live. We need water. We need water. Water is needed for living beings as well as the non-living beings. Water demand become increasing due to the population growth and industries development. In upcoming generation, by 2025, water demand will 1/3 of the population will face the severe water shortages. In the world, 97% of water is salty water, only 3% of water is fresh water, and most of this water is unavailable forms, which is glaciers and ice caps. Only 1% of water is accessible as surface fresh water. Water consumption, in the 90% of water, 85 to 90% of water can be used for irrigated purposes, 7% of water is used for industries and livestock, and only 3% of water can be used for domestic purposes, which means which used to household, indoor, outdoor household purposes. Increase the water use efficiency will reduce the water shortage as well as greatly contribute to the poverty reduction. Black gram is main important grain legumes cultivated in Sri Lanka. It can be cultivated in several districts. In the black gram yield is 1.5 to 2 tons per hectare. It can be obtained. The data can be get from the Department of Agriculture website page. Black gram seed is consumed in several forms, and black gram consists major protein content, which is 25%, and it consists of vitamins and minerals also. Black gram can be used for several purposes, to cook dal, soups, and it will increase strengthen the nervous system as well as which has higher fiber content. Normally, black gram can be cultivated under low moisture and fertility condition. 80% of black gram can be cultivated in Maka season as rainfed plants, and only rest of the part is cultivated in Jala season with supplementary irrigation. My main objective of my research is to evaluate the growth performance of black gram MI1 variety in different irrigation water management practices, as well as to evaluate the yield performance of MI1 variety in different irrigation water management practices. Materials and methodology. Study area. My research was conducted research field of Faculty of Agriculture, University of Jaffna. About my research is about my study area is it is located in Arigal Nagar
Nagar in Northern Province, agroecological region, rhizome low Congress, soil type, red yellow letto soil and mean annual rainfall 1040 to 1250, average temperature 28 and 34 degrees C. Experimental design. My research was conducted randomized complete block design with 3 replicates. I used 4 treatments: flat basing, residual moisture, rich and furrow, raised bed, residual moisture is as a control. Mean separation was done at Dangan multiple range test at the p-value 0.05. And this is the layout of my field. Each block consists of 4 treatments. This is the real field. Investigation of existing field condition. I measure the physical properties of soil particle analysis, field capacity and the infiltration rate. Bulk density of soil, particle density of soil, porosity of soil should be measured through this equation. This is the pictures getting from soil particle analysis using sieve. This is the procedure used for measure the D10, D30, D60 values. Finally, I measured the uniformity coefficient and coefficient of gradient by using this equation. Infiltration rate should be measured by using infiltrometer. This is the procedure used for measuring infiltration. Field capacity also measured by using these procedures. Agronomic practices. Normally land preparation, sowing, irrigation, fertilizer application, crop density management, pest and disease control and harvesting. Land preparation. Normally land preparation should be done using two-wheel tractor and carried by Mamboti. There are 12 plots. The bund is a little bit large to reduce the seepage losses. Sowing of seeds per sown at 30 into 10 cm spacing. Irrigation should be done in water can, and amount of irrigation should be done in according to the treatment. Finally, I measured how much of water should be applied in the period, and the equal amount of water was applied in each treatment except the residual moisture plot. Fertilizer application should be done according to the Department of Agriculture recommendation. Thinning out, weed control also done. Pest and disease control, if necessary, pest and disease control also done in my field. Harvesting should be started 65 days after planting. Finally, I measured germination percentage in growth parameters, plant growth, canopy width, reproductive parameters, number of flowers per hill, yield parameters, number of pods per plant, number of seeds per pot, length of the pot, seeds weight and yield. Statistical analysis should be done. SAS 9.1 and mean separation was done by using Duncan multiple range test. Irrigation water use efficiency, finally irrigation water use efficiency measured through this equation. Results and discussion. Through these results and discussion, soil is well graded because coefficient is range is above 4 and the coefficient gradient is range is 1 to 3 is soil is well graded. And soil parameters also 26% field capacity, infiltration rate 27%, 77 mm hour. Plant growth parameters. Highest plant growth was observed in rich and furrow bed. And canopy width, there is no significant difference in observed in canopy width, but highest was observed in rich and furrow bed. And average number of plants is highest was observed in rich and furrow, and lowest was observed in residual moisture plot. And average number of pods per plant was observed highest in rich and furrow, lowest was residual moisture plot. And there is no significant difference was observed in length of the pot. This is the maximum number of seeds per pot was observed in flat basing treatment. 100 seed weight was maximum was observed in rich and furrow method. And the yield, highest yield was obtained in rich and furrow method, but there is no significant difference was observed in rich and furrow and flat method. Irrigation water use efficiency, best method for economic efficiency was compared to other method, rich and furrow method. Conclusion, rich and furrow gave significantly higher black gram yield and as well as the it will increase higher water use efficiency. So when comparing other methods, economic efficiency is high in rich and furrow method. And from the black gram indicated and rich and furrow method is recorded 41% of increase yield over the residual moisture treatment. Finally, the study suggests farmers in the northern region having limited amount of water for irrigation that rich and furrow treatment recommended for profitable cultivation. Suggestion should be repeat the experiment in Jala season, conduct the experiment in other varieties of black gram.
Okay, thank you, Ms. Jalini. It's a nice presentation with more details of your findings. I have one thing to get your idea that have you go through any cost estimation for these separate methods?
Cost estimation? No, still not identified.
Okay, when you go for the second session for the yellow season, it's better to go for the cost estimation because some land professionals have need some more labors than others. So it could be facilitated to get the more findings in yellow season as well. Okay, then thank you very much. Thank you very much for your participation. Then let's move to the next presentation. Yeah, topic number 4, effect of alternative wetting and drying technique on water productivity of paddy in major irrigation stream. A, case study in Mahavali system. B. The case study in Mahavali system B. I would like to invite to that presenter Mr. Artigal to conduct his presentation.
Good morning all of you. Madam. The topic is effect of alternate wetting and drying technique (AWD) on major irrigation schemes Mahavali system B. The AWD technique also water saving method in paddy, and about 20% of water saving can be obtained in other techniques, and it's a simple method and predetermined water requirement is supplied for the fields. When you consider the situation of Mahavali system B, it belongs to Ponderman vertical districts and it's in dry zone, therefore the rainfall was low and the main water reservoir is Madurai and its capacity is 596 million cubic meters and the extent is 25,000 hectares of land. In the future planning Mahavali system B, it earlier decided left bank and right banks and already carried out in left banks, so in near future it will be planned to start right side. So additional land increase about 20,000 hectares of irrigable. There may be main future problems, it's water scarcity. There is a few solutions for these problems. We can improve the water management in farmer level and we can improve the water conservation mechanisms and we can apply AWD techniques. So our objective was to estimation of water productivity and development and recommendation of the best irrigation system for the farmer. The two fields were selected when there were two farmers and the plot size was 0.1 hectare. There were two treatments, conventional irrigation and AWD irrigation. There were 5 replicates and the location was Kudava unit in Mahavali system B. In one field, we apply AWD method and in another field, the farmer applied conventional irrigation method. And it comes to the water consumption and the yield of these two fields. The data analyzed using our CBD. And in this field condition and management practices maintain in same condition and land preparation by using time tiller and rice variety was B352 fertilizer recommendation. And establishment of a field water tube. Establish a field water tube in paddy field to monitor the water depth. The water tube is 20 centimeter height and 10 centimeter diameter PVC pipe, and hammer the tube into soil and up to 50 centimeter depth and 5 centimeter above the soil surface. Remove the soil in the tube. The AWD implementation was started 2 days after seedling, 2 days after broadcasting. After irrigation, water dropped down to about 15 centimeter. Reloaded. 1 week after and before flowering, field were kept flooded. And after flowering stage, again apply AWD till 2 weeks before harvesting. The data were collected, the yield, the number of irrigations, water productivity, yield from water consumption was recorded. The results, when we consider the irrigation interval, according to the results, by using AWD irrigation technology, we can save 2 water issues. And in the AWD treatment, we observed that in the early stage, the water requirement is lower than the later parts. And when we consider the yield, the higher yield was observed by AWD practice area, while the lower yield was shown by control. When we consider water consumption, the higher water consumption was observed by control, while the lowest was shown by AWD treatment samples. When we consider the water productivity, the highest water productivity was observed by AWD treatment samples, while lower water productivity was shown by control. When we summarize these results in conventional and AWD technique, the highest yield and highest water productivity was recorded in AWD technique while using the same water amount. Thank you.
Okay, thank you, Mr. Artigala, for your nice presentation. According to your conclusion that AWD is the best, very impressive findings that. So I want to clarify one thing from you. Did you calculate or measure the water volume to supply the both irrigation methods?
Yes, sir. We have calculated the water volumes because we have the equipments with our. We have equipments with our irrigation section. Our irrigation engineer has done this work.
Okay, then thank you very much. Nice finding. Okay, let's move to the next presentation. Okay, last presentation topic is effect on non-woven fabric material, a crop shield on leaf curl complex, growth and yield of performance of chili. The presenter is Mr. Kumar. So I would like to invite Mr. Kumar to conduct that presentation.
Good day to all of you. I am Mangala Kumar from Department of Agri-Technology, Institute for Agro-Technology and Rural Science, University of Colombo. First of all, I am thank you, sirs and madams, for giving opportunity to me. I did my research regarding effect of the non-woven fabric material, a crop shield on the leaf curl complex, growth and yield parameter of the chili. Dr. MP Vidhanapatirana and Mr. TGB Tanuskar guide me throughout the research period. This is the content of my presentation. You may certainly know that essential condiment in Sri Lanka, it belongs to Solanaceae family. The average extension of chili cultivation acquisition is around 13,000 hectare, while annual consumption of the dry chili and green chili around the 16,000 and 63,000 metric ton respectively. In here you can see the world top chili producer, which is the China. Green chili is the highly susceptible to pectin diseases, mainly viral infection due that farmers are using the massive amount of agrochemical, which is the seriously environment harvest as well. Propsil was introduced to minimize of the pesticide use in the chili cultivation. The origin of the crop seal is Israel product. It protects crop from insect pests, heavy rains, animal attacks, sunburn, forest injuries, and vegetable and fruit trees. You can see the Agriplast crop seal in here using chili cultivation from India. I cultivated MICH HY1 variety, which is developed by the Department of Agriculture and moderately resistant to the chili leaf curve complex. Potosa MICH HY1 chili in my research. We identify those problems in order to conduct research which ultimately have the adverse effect on our soils and environment. Moving on the objective, my main objective is the same as research topic, while especially objective under that we are identification of the effect of the non-woven fabric material of seal on growth and yield parameters of hybrid chili MICH HY1, identification of possibility to the reduce agrochemical using by crop seal. I choose two sites for my research, which are Institute of Agrotechnology and Rural Science, University of Colombo, Valleygatta, Ambantota, and Sampath Agropam, Surya. After sites we fix RCBD design was used for the experiment. Pre-treatment was used as mentioned for the dose blocking. Treatment 1 control, treatment 2 application of recommendation insecticide, treatment 3 application of the crop seal. 112 plant was used for each treatment. Here you can see the field layout of the experiment. The primary land preparation was done by disc plug and back machine, and second land preparing was done by the tiller as Namatis manual. For nursery establishment was used nutrient added the cocopel, Sita treat with thymosine 17 was at planting. 11 feet wide, 35 feet long, 7 feet high crop seal was applied as the mini protect house with the support of the temporary structure, as you can see for the picture. When the time was suitable for transplanting, we did it by choosing pet and diseases preceding according to due criteria. From treatment 2, we did recommended chemical application from Department of Agriculture, as you view from this. Under common management practice, we added fertilizer, basal dressing, top dressing 2 mentioned in the other than recommendation sprinklers for vegetables were used for the watering purpose. when considering the data collection part, growth, yield, diseases, stress, and few other parameters have been taken as mentioned in there with proper tools and equipment. As we know, data analysis is the one of the major important thing for the research, and our proceed as comparison of the mean was done by DMR proceed. Together with that, pool test was applied to the analyze weather parameter. Okay, let's move the result and discussions. As you can clearly observe from this graph, when we talking about the pests and diseases attack on chili, control is effect with the highest number of the case with the treatment 3. This is having the crop seals has none, had none. You can view which next video clip also. Treatment 2 which is apply recommendation insight also you had higher numbers the case, but this is lower than the control. When talking about the high of the plant, significant variance treatment tree in the gap. Plant width is very high crop seal, significant variance in other. Cumulative number of leaves per plant is significant variance no treatment or. Cumulative number of branches per plant here. When consider about G parameter, average pot weight, all are not significant variance. Also, you can see average pot length of the chili variety. Treatment 3 had the most, while treatment 2 had the lowest. Cumulative harvest of the chili after 12 weeks per plant around the 1000 gram in the treatment 3 and 2 while control had around the 800 gram harvest per plant. In those graphs, you can see temperature and humidity effect by using COPSI. The effect of the COPSI on the light intensity displayed here. Cost analyzed for the 1 acre in the recommended pesticide application was COPSI in here. Finally, as the conclusion and recommendation can say that Copsil effectively control pattern diseases incidence of the MICH-HY hybrid chili. Internal lengthen plant height of the chili transfer significant increase by the Copsil. By using Copsil, genetic potential of the MICH-HY chili yield was achieved. Reference here. Time term here. Finally, you give me your time, that most truthful gift of you. I am forever grateful for your part in my journey. Thank you very much, sir and madams.
Okay, thank you very much for your impressive and more detailed findings, Mr. Kumar. A few things I want to clarify from you. First thing is, why did you use that moderate resistant varieties except to successful variety for the leaf curl?
Yes, sir. 80% commercial farmers are using hybrid variety, especially chili. They farmer want to the more productivity and efficiency, but hybrid varieties not 100% leaf curl complex. Leaf curl complex.
Yes, then leaf curl, then that variety was not 100% resistance to the viral infection. That is the most cultivated variety in Sri Lanka. That's belong to hybrid varieties.
Okay, thank you. Another thing is, are there any countries you already use this top shield, not in trials, maybe practically? Can you hear me? Mr. Kumar, are there any countries already use this crop shield for their cultivations?
Yes, sir. India, China, and Israel must use Copsil in the chili variety.
Okay, then thank you very much for your presentation. Okay, we have already explored 5 research findings presented by authors, and thank you very much for your consideration to share your valuable finding with this session. Thank you very much.
Thank you very much, sir.
Yes, thank you very much, Mr. Hasanaka, for your kind cooperation with this session. Then after that, I would like to thank all the presenters who are sharing that, were sharing their valuable knowledge with our symposium. Then this is the end of the technical session number 3. Then thank you very much.
Okay, thank you very much. Session Chair, Mr. Hasanaka Rowandiran, Coordinator for Technical Session 3, Mr. TGB Danushka, for their contribution. Okay, now we have completed Technical Session 3, and now we are going to start last technical session of this symposium. Session Chair for this technical session is Mrs. Nelka Srivarnasinghe. She was graduated as BSc Agriculture graduate from University of Ruhuna, Faculty of Agriculture. She has completed her Master in Agriculture Economics and Development. She has been working at UCIARS since 2010 and contributed to develop the Bachelor of Agrotechnology program for farm community. Also, she is a member of research team in UCIARS. So, I cordially invite Mrs. Nelka to chair the session number 4.
Thank you very much, Mr. Rasika. Good evening, all of you. Welcome all for the technical session 4. The theme is Harnessing Agriculture Research for Rural Communities. I would like to invite the first presenter in the first presentation. The topic is Identification of Agricultural Students' Perception, Knowledge and Constraints to Organic Farming and Consumption. The presenter is Ms. MGP Sankalani. Ms. Sankalani, this time for your presentation.
Hello everyone, I'm Sankar. Today going to present research findings under the topic of identification of agricultural students' perception, knowledge and constraints to organic farming and consumption. Let's begin with a simple introduction. Much of the agriculture sector in Sri Lanka has become dependent on agriculture chemicals. Synthetic pesticides, growth regulators are widely used because of the increasing demand for food quantity from the limited land area. As you can see in the picture, conventional farming system performance are limited into several aspects such as crop yield, profitability, etc. But organic farming can balance all the aspects, including social, environmental, for example, soil fertility, biodiversity, etc. Healthy soil from organic farming can make healthy foods, and healthy people, finally healthy society. In simply, organic farming is a sustainable production system which avoid use of synthetically compounded fertilizer, pesticides and other chemical compounds. First graph shows the growth of organic agriculture lands in Asia from 2000 to 2014, while the second graph shows the growth of organic lands in Sri Lanka from 2005 to 2011. Main objective of our study was to identify constraints to organic food consumption, and another specific objective was to identify students' knowledge and perception of organic agriculture practices. Moving on to the material and methods, our study area was Faculty of Agriculture, University of Pune. The research was conducted as a survey. Questionnaire was developed for fulfilling objectives. There are 3 degree programs in the faculty and random sampling of each academic year was considered. Talking about the results obtained, here are some demographic characteristics of the students. 36% was male and 54% was female. From the 3 degree programs, representation of each degree program were considered. Asking about the awareness of organic concept, most of the students are aware of organic concept before coming to the faculty, while some of them are not aware. But after coming to the faculty, all of them are aware of organic concept. As awareness sources, they have mentioned mainly lectures, social media and internet, books and newspapers, etc. To identify students' knowledge on organic farming, 7 pre-decided statements were used. Most of the students have selected 6 corrected answers out of 7. As you can see in the results from the table. With the results, we can decide that most of the students are with good knowledge of organic farming. Then Students are advised to rank the constraints considering their own experience. From the results, we have identified the main constraints as high price, while no outlets, no concern, no farm in respective areas, no trust about organics are other constraints. Here are few suggestions to promote organic agriculture, which is arise from the students, bring price into affordable level, increase government intervention to promote organic farming, conduct more R&D programs, aware people more about organic farming and its benefits, make organic foods more available, supply subsidies, technical knowledge among organic farmers. As conclusion, agriculture students have good perception toward organic farming and organic foods. They are with good knowledge about organic concept and farming practices, and major constraints was identified as high price. Here are my references. Thank you for your attention.
Okay, Ms. Sankalani, thank you very much for your nice presentation. I have a small question. In your results and discussion, you mentioned that in your study, some students mentioned that they have no any concern about organic foods. They have no concern about organic foods. That means in their area they have no any organic foods, right? What can be the reasons for such answers?
Madam, there is another question we have focused about that concern matter, that normally when they come into the university, they are somewhat not concerned about their food. That for example, in the home they have nutritious foods. Likewise, then when they came to the hostel, they have not much that facilities. So that's why I think they are not concerning the nutritional values and all that.
Okay. Here, actually, what did you mean by organic food?
Normally, organic foods we didn't use synthetic chemicals, fertilizers, pesticides, like that things. They are natural fertilizer. They use natural fertilizers and different crop rotation, likewise things.
Okay, Ms. Sankani. Thank you very much for your contribution. Then let's move to the second presentation. Second presentation is a study on factors shaping net profit on groundnut farmers in Ampara district, Sri Lanka. The presenter is Miss V. Ravintira. Miss Ravintira, this is the opportunity for your presentation.
Today, I'll present about a study on factors shaping net profit of groundnut farmers in Ampara district, Sri Lanka. First, we'll see the introduction part. The groundnut production is mainly concentrated in Africa and Asia. Sri Lanka also Asian country. In Sri Lanka, groundnut is cultivated in highlands during mass season under rain-fed conditions, and in paddy lands during dry and intermediate seasons under irrigations. Groundnut is a subsidy crop cultivated by small-scale and large-scale farmers. Net profit is shaped by several factors: skill of farmers, cost of input, then new technologies that determines the sustainable cultivation of this crop. There are few empirical studies carried out on the factors that determines the net profit of groundnut farmers in Sri Lanka and especially in Ampara district. Given the importance of this pulse crop production in Tirukol DS division of Ampara district, the present study was undertaken. Objective Objective is to find out the factors shaping net profit of groundnut farmers in Tirukol DS division of Ampara district, Sri Lanka. We will see the methodology part. The study was carried in Ampara district. The target population of study was groundnut growers in Tirukol DS division of Ampara district. The sample population consists Tirukkoil 4, Vinayapuram 1, Vinayapuram 3, Vinayapuram 4, Sangamam, Thangavelaidapuram and Kanjivudiyar GN divisions. Simple random sampling method was practiced to select the 75 growers for this study. Data was collected and analyzed through SPSS software. Descriptive analysis and correlation analysis were employed. Results and discussion. The socio-economic characters of farmers of this study is revealed. The mean age of farmer is 48. The average monthly income is 15,800. Average family size is 4 and average farming experience is 16 years. Majority of these farmers had used to river water to irrigate their land. 15% of growers used agro wells for irrigation. Rest of the farmers used tube well. Most of the farmers hired male and female laborers for farming activities. Farmers got seeds from several seed sources such as peer farmers, Department of Agriculture and own seeds. Nearly 60% of farmers sourcing seeds from peer farmers, followed by Department of Agriculture and own seed. They sold their groundnut products to several market outlets such as village traders, middlemen, wholesalers and Department of Agriculture seed divisions. Average net profit was high in Jala season compared to Maha season. Majority of the groundnut farmers practiced mechanical weed control methods. Around 3% of farmers practiced chemical weed control. Around 20-60% of farmers practiced both methods to control weeds. Pest and disease is a major problem. Major diseases were identified such as stem rot and wilt. Major pests were leaf-eating caterpillar, pod borer and termites. Groundnut growers didn't practice integrated pest management techniques to control pest and disease. They mainly depend on chemical method to control pest and disease. Correlation analysis between net profit of groundnut farmers in Jala season and selected independent variables. The net profit is significantly affected by two independent variables such as age of the farmers and average monthly income. In the case of age of the farmers, if the farmer has higher experience, so the farmer used their own experience to cultivate and get the higher profit. Then in the case of
groundnut farmers in Sri Lanka? Can you hear me?
No, madam. This only for the Ampara district.
Yeah.
Yes,
What's your...
there is a correction in network, I think.
Okay.
It
Now
is
we can...
only done for the Ampara district, so it is mostly suitable for the farmers which are in the Ampara district.
Yeah. Ampara district in, I think it is in
Can you
rice.
hear my voice, madam?
Yes. Clearly we can hear you. Okay, Ms. Ravintira, thank you very much for your contribution. Okay.
Thank you, ma'am. Thank you, ma'am.
Okay, then let's move to the next presentation. Presentation 3. Major constraints related to tea leaves production in smallholders. A case study in Kottakola DS Division, Sri Lanka. The presenter is A.M. Vitharana. Mr. A.M. Vitharana, I would like to invite you to present.
My topic is major constraint related to the leaves production in smallholder. Introduction. Plant of the comprise unusually large amount of flavonoid derivatives, hence these compound show positive effect on human health. Also, tea is one of the world's most widely consumed beverage and it is mainly produced by countries like China, India, Kenya and Sri Lanka. Sri Lanka ranked higher among the other countries that are exporting tea to the world population. Also, tea as one of the main plantation crop other than rubber and coconut, who are currently contributing to the gross domestic production of the country under the agriculture sector. In Sri Lanka, tea cultivation is mainly based on the central part and southern part of the country with district quality. Upcountry tea cultivation contribute with large-scale entrepreneurs, and low-country tea cultivation in compromising with small and medium-scale entrepreneurs. Our research problem currently the medium and small-scale tea producers are facing several constraints related to countries' tea production. This drawback may result the several losses in the cultivation. Finding a solution to those drawbacks are very much important to sustainability objectives. Therefore, the main objective is these studies to identify the main reason that the farmers are facing for tea production in small and medium scale levels through the primary survey. Methodology. Kottakola DS division in the mother district of Sri Lanka was selected. District farmers were collected by TSH as the population in the selected area. The sampling technique was the sample random sampling. 50 farmers selected as the sample. The data were collected through a structured survey questionnaire. The questionnaire was designed to achieve objectives. The questionnaire covered the different limitations of the tea cultivation on low country, small and medium entrepreneurs, such as technology, extension service, marketing and economic aspect. Apart from the general issues that the farmers are facing in the area, some basic information of the farmers, gender, education background, land area, education of farmers also concerned for preparation of questionnaire. Data analysis. The 5-point scale ranging from 2 to 2 was used to calculate numerical figures for particular constraint that the farmers are facing. For the analysis of data, SPSS software was used. Regarding discussion, background, the majority of farmers are males. Education level of the majority of the farmers are in between grade 8 and ordinary level. Most of the farmers are cultivating tea for a long time. The land area of the most respondents are less than 2 acres. The respondents were significantly agreed that the climate condition, especially the lower rainfall and the higher rainfall, both got affected for the low production of leaves in this area. Then the lack of use of fertilizer and inefficiency weed management also got significantly lower production. Once the tea leaves were harvested, the post-harvest losses also significantly contribute to the lower production in the area. Nowadays, finding labor a serious problem in any cultivation or production. Hence, the labor shortage also significantly affected the low production of tea in the area. Improper use usage of technology and incorrect pruning greatly affected the production level. Conclusion: we can conclude that constraints such as extreme climate condition, inefficient fertilizer application, improper weed management, severe post-harvest losses, labor shortage, not adopting efficient technology are directly affected for the production level of tea. So the precision farming technique should use to minimize the issues related to the cultivation. Thank you.
Okay, thank you very much, Mr. Vitarana. You addressed the current problem in the country. Now the presentation is open for the discussion. Can you give me one suggestion to improve the tea quality? Okay, I think there is a technical issue with the connection. Okay, anyway, thank you very much again for the Mr. Vitarana. Then let's move to the fourth presentation. The topic is awareness of the entrepreneurs regarding the application of the chemical fertilizer and the pesticides on banana cultivation in Ambalantota and Suryava DS division. The presenter, Mr. B.P. Sirivardhana. I would like to invite Mr. B.P. Sirivardhan to present.
Thank you very much. Right, warmly welcome all of you. The topic is the awareness of the entrepreneurs regarding the banana application of chemicals in banana cultivation. Sri Lanka, the Ambalantot and Surya division. So the introduction, and banana, one of the most consumed fruit in the world, and it also same as for the Sri Lanka too. And it has been considered the banana fruit is having the properties of lowering blood pressure and reducing the risk of cancer and asthma. And we will move to the problem identification and justification. Although the application of chemicals serves as a benefit, but also had the long-term harmful effect the environment and human health. And farmers do not having the knowledge regarding the effects of these applying liquid fertilizers. They only using from their previous experiences. And occurring health problems due to the spraying of chemicals in appropriate or non-recommended levels to the cultivation. So they do not do any calculation or do not measure the things that actually they need. They only applying as a habit. Therefore, the knowing the effect of these liquid fertilizers are very much important. I mean the knowledge levels of the farmers regarding these chemicals. Therefore, the objective of the study is to measure the knowledge levels of chemical application on banana cultivation by farmers. Under the methodology, and we have selected the location Ambalantota and Surya DS division in southern province Sri Lanka. 50 number of farmers was selected as a sample size out of the total population, and the applied this simple random sampling technique. There were two data, primary and secondary, and both data were calculated to the final observations, and then the data analysis and interpretation. So the most valuable section of the presentation is the result and discussion. So the first, different banana cultivars cultivated by the farmers. So out of that sample, majority of the farmers are cultivating Kolikuttu banana variety than the Ambul and the Chili. So you can see 88% of banana farmers are cultivating Kolikuttu banana variety. And then the usage of foliar nutrient mixture, and majority of the farmers are stated that the 78% by they are applying the foliar nutrients, and only the 22% of the farmers are not applying the foliar nutrients. It means majority of the farmers are applying these nutrients. And then the application frequency of that nutrients are diverse time period, 1 time, maybe 2 times, and then 3 times, or maybe 4 times. So the majority of the farmers are applying chemicals for the 3 times. It means 75%. So there are farmers who apply 4 times also, but the majority is 3. And then we will see the intervals between one application to the another. So the 7-day interval, I mean the 1 week interval is considered as 67%, and the 10-day interval is 11%, and 14-day interval, it means 2 weeks, is 22%. So the majority of the farmers are applying this nutrient in a 7-day interval. So when we run on the test of Wilcoxon-Sign-Rank test, we can have that the knowledge level of the pesticide, fungicide and fertilizers of the farmer and the knowledge level on application of the pesticide and fungicide and these fertilizers and their function, and also the application of chemicals in recommended level, and what are the ingredients in that chemicals, and also the application methods of that chemicals, I mean the precautions, and also the knowledge levels on side effects and their benefits, and then the safety precaution, like those all factors got significant, mean less than 0.05 significance level. So when we move to the conclusion, most of the farmers tend to grow Calicut to banana, and with that NAPGET gives super chemical foliar fertilizer mixture for increase the harvest, and majority of the farmers are applying these nutrients in a 7-day interval, and most of the farmers are applying these nutrients for 3 times for until the harvesting. So these are my references, and thank you very much for joining.
Okay, thank you, Mr. V. Srivardhana. I have small questions for you. One is there any agriculture department recommendations for applying those foliar nutrients for the cultivation?
Yeah, there are recommended levels of applying these foliar nutrients to the banana cultivation.
Another one is there any negative effect of applying those foliar nutrients to banana?
Yeah, actually, we have to continue this research for a long time, and otherwise it is difficult to say exactly these nutrients affecting for the health. But from this study, we have done some kind of analysis regarding the heavy metals, and it showed us there are no any heavy metals of this foliar nutrient. But I'm afraid that we cannot conclude like as it is. We have to continue this research for several time periods.
Okay, thank you, Mr. B. Srivardhana. I think it's a timely study, Sri Lanka. Thank you very much.
Thank you very much.
Let's move to the presentation, fifth presentation. That is consumer attitude and awareness on organic foods. A study on urban areas in Sri Lanka. The presenter, Miss W. M. A. M. Bandara. Miss Bandara, I would like to invite you for your presentation.
Okay. Good morning all. I'm Bandara from Faculty of Agriculture, University of Pune. At present, there is an increasing trend of getting non-communicable diseases. So people are very keen about the health effect of the food that they have taken. So now consumer attitudes are directed towards the consuming organic food. So this study is on consumer attitude and awareness on organic food in Sri Lanka. Study conducted in urban areas in Sri Lanka. First move to the introduction. What is meant by organic food? Organic food are the food products that are produced, processed, packed and sold without using chemical fertilizer, pesticide or any other artificial chemicals. When consider about the importance of organic food, as you all know, they are healthy, environmental friendly and produce and consumption of organic food line with the sustainable development goal. Significance of the study. In the recent years, growing consumer concern for safe and healthy food as well as increased environmental concern, especially in larger cities in Sri Lanka, has shifted the demand towards alternative healthy products such as organic food. There are a number of studies conducted in global level related to this, but there are very few studies conducted in Sri Lanka. So it is important to study about the consumer attitudes and awareness on organic food in Sri Lanka. So under such background, we set the objective to the study. General objective is to identify the consumer attitude and awareness on organic foods, and there are three specific objectives. Let's move to the methodology. The sample of the study consists of 100 consumers in Colombo district. Those are supermarket consumers in 4 different locations of the Colombo district. There are 25 from Rajagiri area, 25 from Bellavatta, 25 consumers from Peta, and another 25 from Nudegoda, using purposive sampling technique. Primary data were elicited from both field observation and questionnaire survey. Secondary data collected from journal articles, websites, and books. Data were analyzed using both descriptive and inferential statistical technique by SPSS software. So now we move to the result and discussion of in this type of studies, it is important to analyze about age, gender, income-like factors, because such factors are directly affect consumer buying behavior and food consumption pattern. So, socio-demographic profile of the study summarizes that majority of the consumers belong to middle-age category of 35 to 50 age group, and majority of them are female. Family structure of the consumers reveal that 44% of them having 4 or more family members in their family. Income level of the consumers in this study reveal that 54% of the consumers are earning more than 40,000 rupees income per month. According to the second objective, attitude of the consumers regarding organic food are analyzed. According to that, 79% prefer to buy organic food, while 96% believe that organic products are healthier, and another 92% believe that organic products are safe and more reliable than the conventional foods. Summary of the average value of each criteria reveal that organic food are higher nutrition value than non-organic food, but consumers believe that organic foods are very expensive and there are not many organic food products are available in the Sri Lankan market. Consumer trust also analyzed regarding food products and organic food producers. In Sri Lanka, consumers neither trust organic food products in the local market than the organic food producers in Sri Lanka. As the consumer attitude, it is also important to analyze the awareness regarding consumer on organic food. So in this study, we use 3 main organic food product logos available in Sri Lankan market. One is Organic Food Safety Management Certificate. The second one is USA Organic Program Certificate, and final one is Bio Certificate. So certification logo recognition by the consumers reveal that majority of the consumers do not adequately aware about the organic food product certificates in the market in Sri Lanka. However, the sources of awareness about the organic food of the consumers reveal that majority of the consumers in this urban area aware about the organic food through television, followed by the newspapers. Finally, suggestions for increasing the consumption of the organic food is revealed by the consumer point of view. So consumer gives several suggestions. As you all know, consumers do not have positive perception toward the price of the organic food. So majority of suggest that price should be fair for both consumers and the farmers. And Almost all the consumers believe that organic food should be popularized among the people and consumers should be aware about the importance of organic food products they consume. When compared with the non-organic food, organic food are not much attractive. So 78% of them suggest that taste and appearance of the organic food should be increased while preserving their nutrition and health benefit. And also they suggest availability of organic products should increase while need to introduce a variety of organic food products to the Sri Lankan market. These are the conclusion driven from the key finding of the study. In Colombo region, majority of the consumers prefer to buy organic foods, but relatively high price of the organic food than non-organic and unavailability of sufficient organic foods in the local market are the major constraint faced by those consumers. More than 60% of the consumers do not trust both organic product and organic product producers in Sri Lanka. 77% of the consumers suggested to maintain a reasonable price for organic products, while 78% highlights the importance of increasing the taste and appearance of the organic food. Also, action are needed to taken in order to increase the availability of organic food in Sri Lankan market. Here recommendation based on the conclusion of the study. The government policies and regulation should be introduced in order to increase the consumer trust toward organic products. Awareness raising of both consumers and producers along with standards of the logos and certificates available in Sri Lanka also important. Offer the organic product at proper price and the proper quality is also increase the consumer satisfaction, finally leads to increase the demand for organic foods. And finally, action should be taken to increase the continuous supply and the availability of organic product. Especially the diversified organic food products in the local market is crucial to attract consumer towards organic food in Sri Lanka. Here are references and thank you for your cooperation.
Okay, thank you very much, Ms. Bandara. It's a good study. What are the available organic foods in the market now? Did you search for that?
In supermarkets, there are in supermarkets, there are organically origin coconut products, coconut oil, scraped coconuts, and also some products derived from organically produced rice varieties in both Kills and Kagis like supermarkets. And also in Colombo region, especially in Colombo area, there are specific outlets that serve organic food as good market in Colombo and Knockhat and such. There are several shops. They are especially for delivering the organic foods. It includes both cereal items and cooked kottu likewise. And in supermarket especially we can find organically origin coconut products, rice product and those things.
When the organic foods, consumers are willing to take organic food as a non-toxic food, or it should be the totally organic food. What did you mention there when you are testing your questionnaire with your target group?
Non-toxic in this study from the consumers, we specially highlighted the products with organic origin. That means in not only in producing but processing and manufacturing, all those stages do not include any artificial chemical or organically origin.
Okay. If required organic food products are available in the market, consumers are willing to buy them. Are they, though they're expensive, consumers are willing to buy them if the required food items are available in the market?
Yes, the major claim come from the consumer side is one when they visit the supermarket, there are several organic food products available in the racks, but the next time they come to the same supermarket and searching for that product, they are not available. When they ask from the sale officers, they go, we are out of stock. So that's the major claim come from the consumer side. So they are at given price, but they also suggest that if the price should be fair for all the consumers, it will very helpful to grab another consumer group to this organic food. That means actually it's a niche market. As we all know, organic food market is a niche market. Few consumers are involved in that, but those consumers are willing to pay the given amount to buy that product. So availability is the problem. That's the major problem. The rest to the supermarkets not available sufficient amount of organic product in continuous basis.
Okay, thank you very much, Ms. Bandara.
Thank you very much.
Okay, let's move to the next presentation. Sixth presenter, consumer preference for selected eco package on product purchasing behavior, a study in Kahatodua North GN Division. The presenter is Miss DGJS Wijayatunga. I invite Miss Wijayatunga to take this opportunity to present.
Hi, I'm Janika Wijayatunga. I am here to present my research study on consumer preference for selected eco package on product purchasing behavior, a study in Kahatudua North GN Division. These are the authors of my research study. This is the content of the presentation. Let's move into introduction part. In here we talk about eco package. Eco package is any packaging that is easy to recycle, safe for individuals and the environment, and is made out of recycled materials, also known as sustainable or green packaging. These are the aims of eco packaging: lessen the amount of product packaging and promote the use of renewable reusable materials, cut back on packaging related expenses, eliminate the use of toxic materials in the production of packaging, and provide options to recycle packaging easily. These are some examples for eco packets, and you can see in your eyesight these are environmentally preferable eco packages. These are the objectives of my research study: to identify the factors affecting on consumer towards eco package, to find out potential barriers on purchasing of eco package, to provide the suggestions to enhance the usage and purchasing of eco package. Let's move into methodology part. Our population was entire customers in Sri Lanka, and we randomly selected 100 customers in Kahatudua North GN Division. We collected primary data from questionnaire survey, informal interviews, and secondary data from previous research studies. We use bar charts and column charts to descriptive data analysis. And let's move into results and discussion part. First we talk about socio-economic background of the sample. In here, majority of the sample is from male, it's 61%, and then we talk about education level. In here, 38% of respondents have up to GCE O level education level, and it's very less amount, 8% of respondents have above degree level education. In here we talk about customers' consideration about eco package type while they purchasing a product. 62% of sample not consider about eco package when they do their purchasing behavior. And also 78%, the majority of the sample not caring about eco package when they select their day-to-day needs and their foods like that. Now we talk about reason to low level of eco package usage. Our reasons were the cost, not enough knowledge, lack of availability, lack of information, difficult to handle, like that. In here, majority of the sample told that they cannot bear the cost, and 7% and 5% of the sample told that they have a lack of information and difficult to handle, like that. And we can understand the major reason is the cost. Let's say moving to the conclusion part. The environment has become a critical issue that is influencing how products are developed, marketed and disposed of. Customers' consideration and caring about eco package is very less in their purchasing behavior. Consumers are less likely to purchase eco package if the products are more expensive. And these are the recommendations. It's recommended that marketers, educators and policymakers should understand the uniqueness of each market to promote green behavior. It is usually recommended that campaigners should focus on the innovations of eco-packaged products. Higher price harms the consumers purchasing packaged products. It can be recommended that to make presence of eco-packaged products in stores more obvious and to make some advertising campaigns or to give some brochures in order to inform customers. Also, these are the references. Thank you. Thank you.
Okay, thank you very much, Ms. Vijayatunga. Can you explain the parameters taken for the testing product purchasing behavior?
Actually, ma'am, we used total mark scale, like 5-point Likert scale and those scales. Actually, the question is not clear.
What you have used to testing the product purchasing behavior of the consumers?
Normally, ma'am, we ask only questions you buy or not, like that, consider or not, that type of question.
Okay. Okay, thank you. Thank you very much for your informative presentation. Thank you. Okay, next move to the last presentation of this session. The topic is prospective approach for a sustainable agribusiness sector in Sri Lanka, a review. It will be presented by Ms. Tilakaratna. I invite Ms. Tilakaratna to present now.
Good morning. I am Hasika Tilakaratna from University of Ruhuna. I am going to acknowledge you about my study on prospective approaches for a sustainable agribusiness sector in Sri Lanka, a review study. Agriculture plays a vital role in developing countries' GDP aspect, involving large number of labors in it. The advanced technology has been integrated into agriculture, creating much competitive agribusiness ventures worldwide and creating more innovation systems. But comparing to other developing countries, AIS in Sri Lanka is less effective in concerns of information technology. I address these kind of limiting issues in Sri Lankan agribusiness sector and about overcoming these issues. Actually, there can be seen a restoring of conventional crops like cereal by mine export crops like clove, pepper, and cinnamon in world export market, but it has reduced the market share of these crops due to the less competitiveness among the other countries globally uh, in Sri Lanka. Due to lack of data availability and credibility, the RCA index and market share analysis is applied to determine its competitive position, but it is not much appropriate since subjective measurements indicated also have to be used in this since it's a multidimensional model. Sri Lankan agriculture graduates are not enterprising, they are more focused on secure professional careers. This is a negative factor towards the Sri Lankan agribusiness development. It has to be reconstructed the educational system to develop more professional agribusiness entrepreneurs. Some barriers in diffusing sustainable agricultural practices per view of extension educators, like lack of research information and lack of resources to conduct demonstrations. And so it has to give priority for sustainable agricultural practices in extension programs like integrated pest management, educating women farmers on sustainable agriculture, like that. Things are greatly used in diffusing innovations in agriculture worldwide. These are some of benefits of IT in innovation diffusion. It increases agricultural production by using communication channels, and it has the ability to overcome physical distance, and it has the ability to diffuse information in diverse. And these are some of limitations in agriculture business sector in Sri Lanka, such as adverse trade policies, poor trade conduct, the high cost of production, patent protection for traditional products, occupational risk, poor research and development. And there are very useful strategic approaches to develop Sri Lankan agribusiness sector, some of product diversification, mechanization, market development, regional. And it is very important to provide research-based information in diffusing sustainable agricultural practices. These are my conclusions. Sri Lanka has not lacked entrepreneurs, but it has to be given proper education about involving in agribusiness sector successfully. It has to be advancedly used in agriculture for its immense development like IT applications, and should be given the women a priority role in acting towards adopting the sustainable agricultural practices since they are playing an important role in household decision making processes. And there is a better future for Sri Lanka in the field of agribusiness, considering its competitive advantage and prospective strategies to survive and grow up in global market.
Okay. Thank you, Ms. Tilakaratna, for your nice presentation. I have one question for you. What is the university involvement for the producing agriculture entrepreneurs or the agribusiness people in Sri Lanka?
Actually, madam, most of the universities in Sri Lanka have started degree programs related to agriculture and newly for the agribusiness management field. But with the research findings, it's revealed that though the universities produce more agricultural degree holders or agricultural graduates to the society or for the agricultural field in practically, they are not much professionally enhanced with the practical knowledge about the agriculture and the new profitable agribusiness ventures. So I think universities have to strengthen their education curricula to produce more practically educated agricultural graduates with more empirical knowledge, regardless of just the theoretical knowledge.
Okay, do you think if it is enough for just giving agriculture degree and the giving the practicals related to that? Is it enough for the producing agriculture entrepreneurs in Sri Lanka?
No, madam. Some other background supports like resources and the research-based backgrounds have to be uplifted to enhance their practical knowledge and strengthen their involvement to the agriculture sector.
Okay, thank you, Ms. Tilakaratna. Actually, around 10 years ago, UCIARS has started such kind of program to produce agriculture entrepreneurs in Sri Lanka. Actually, thank you very much for your nice presentation.
Thank you very much.
Thank you. That is the last presentation of this session. I take this opportunity to thank all presenters present for this session. Thank you very much, all of you.
Thank you very much, Session Chair, Ms. Milka Srivarnasinghe, for your contribution to Chair Technical Session 4. Ladies and gentlemen, it is happy to announce now we have completed all the technical sessions of this National Symposium. Now it is time for concluding remarks. I think this symposium was a wonderful platform for all the scientists, researchers, graduates, and undergraduates to share their knowledge and experiences under different session themes. First technical session theme was towards zero hunger. Actually, we received 16 papers for our first technical session. The agriculture and ecosystem safety was the theme of second technical session. We received 8 papers. Session theme of third technical session was ensuring the adaptation of suitable innovations. It received 5 papers. The last one, harnessing agriculture research for well-being of rural community. We received 7 papers for that session. So it is excited to announce 36 research papers were received for this first national symposium organized by UCIARS. We hope these research findings, knowledge, and experiences shared through all the technical session would be help to betterment of agriculture in Sri Lanka. So I profoundly thank all the scientists, researchers, graduates, undergraduates, and all the participants for their brilliant support to success of this first national symposium organized by UCIARS. Before closing the symposium, I kindly request all the authors to fill register form that we have emailed you. When you fill it, please be concerned to put your correct address to deliver the symposium kit. Our symposium procedure book have already been uploaded to symposium website, and anyone who wants to see that can visit our website too also. Thank you very much for all joining with us today. All the best. Good luck.
Mm-hmm.